Good afternoon, everyone. Warmly welcome to the subject again. I believe, as per the schedule, there are few teams are ready for the presentations today. Who is going to present today?
So group number 10, we are going to present today. Can we
Yeah,
share the screen?
sure, please, sure.
Can you see the screen? So can you see the screen?
Yeah, we can see the screen.
Okay, so now I will start. Good evening, guys. Today we are going to discuss a very important topic. It's about Boolean algebra and truth tables. This is a really easy topic because you have already learned this topic in your A levels. So before we are moving to our presentation, I would like to introduce my group members. I am Sandini and my other group member is Rashmi. So let's move on to our presentation. In today's presentation, we are going to mainly focus on Boolean algebra, truth tables, how construct a truth table, how get a Boolean expression from a truth table, SOP expressions, POS expressions, logical operators in truth tables, basic laws of algebra, importance of truth tables, and we are going to discuss some practical questions based on this theory. At first, we are going to talk about Boolean algebra. Boolean algebra is a branch of mathematics. We use Boolean laws, Boolean theories, Boolean variables in mathematics so many ways. In truth tables also, we represent truth table values with Boolean variables. That means binary numbers. We represent truth values with number 1 and false value with number 0. History of Boolean algebra. In 1854, logical algebra was published by George Boole 5. Today, it known as Boolean algebra. And 1938, Claude Shannon, he was the first person who applied Boole's work to, to design logical circuits. So from now on, I will hand over this presentation to Rashmi.
Thank you, Sandini. Next slide. So let me explain what is a truth table. A truth table is a visual representation that shows the relationship between input values and their corresponding output values in logic or digital circuit. Let's see how we construct a truth table. Next slide. In a truth table, there are rows and columns. A truth table consists of columns for input variables and an output variable. For example, input variable AB, output variable A and B. For rows, each row in the truth table represents a specific combination of input and show the resulting output value. To find the number of rows used in a truth table, take the number 2 raised to the power of the number of variables. For example, if there were 2 statements, it would be 2 to the power 2. That means there are 4 rows. So let's get an example. Let's consider a truth table for logical AND operator. So now you can see there are 3 columns for one column for P input variable, one column for Q input variable, and other column for P and Q, which is output variable. And there are 4 rows because there are 2 statements P and Q. So 2 to the power 2 is 4. That means there are 4 rows. And all the possible combination of zeros and ones for P and Q included in this truth table. In this truth table, you can see when the both P and Q is 1, the output is 1. For others, the output is 0. Now, Sandini will explain how we get a Boolean expression from a truth table. Sandini?
Okay, now we are going to talk about how to get a Boolean expression from a truth table. So there are two main ways to get a logical expression from a truth table. The first one is SOP expression, sum of product. The second one is POS expression, product of sums. A sum of product expression is a Boolean algebraic expression in which different product terms from inputs are summed together. So let's discuss about SOP expression with a practical example. So here we have the truth table of a 2-input OR gate. To obtain a SOP expression from a truth table, first we have to identify the rows in the truth table where the output is equal to 1. And you can see that there are 3 rows with the where the output is equal to 1. So second, we have to write down the inputs for each of these rows as separate terms. I have already wrote down all these inputs as separate terms. So here you can see that these two variables are connected with logical AND operator, and these 3 terms are going to connect with logical OR operator. That's we call it SOP expression. After simplify this full expression, we can get the final answer as A plus B. Product of sums, POS expressions. When two or more sum terms are multiplied, the result expression is a product of sums. Now we are going to see how to get a POS expression from a truth table. To obtain a product of sum expression from a truth table, first we have to identify the rows in the truth table where the output is equal to 0. In this example, you can see that there's only one row with the output is equal to 0. So second, we had to write down the inputs for each of these rows as separate terms. I have already wrote down all these inputs as separate terms, and you can see that these two variables are connected with logical OR operator, and the terms, the 0 where the output is equal to 0, these terms are going to be connected with logical AND operator. That's why we call the product of sum expression. So here we have only one term where the output is equal to 0. So we can get the final answer as A plus B. Now Rashmi is going to talk about the logical operators in truth tables.
Okay, so let's see what are these logical operators. Truth tables are used in logic to help determine the truth or falsity of a statement. They are used to perform logical operations in maths and check whether the proportional expression is true or false as per the input values. There are 5 types of logical operators. Negation, conjunction, disjunction, implication, and biconditional. So let's talk about logical negation. The negation of a statement is also a statement with a truth value that is exactly opposite that of the original statement. The negation operator denoted by these symbols. So let's get an example. For this example, let's get P as it's raining outside. So the negation of P is it's not raining outside. Let's look at our truth table. You can see if P is true, the negation of P is false. If P is false, the negation of P is true. So this is about logical negation. So let's talk about logical disjunction. A disjunction is a kind of compound statement that is composed of two simple statements formed by joining the statement with OR operator. To explain this more, let's look at an example. In this example, let's get two statements. P as Alex studies hard, Q as exam is easy. And the disjunction of P and Q is passing the exam. So let's look at our truth table. Now you can see in this truth table, the overall disjunction is true if either statement P or statement Q is true. If P or Q is true, the disjunction of P or Q is true. That means Alex must study hard or the exam needs to be easy to Alex to pass the exam. Now let's talk about logical conjunction. The logical conjunction is a logical operator that involves two statements and determines whether both statements are true. It is often represented by the word and. So in here also, let's look at an example. In this example, there is an award ceremony. To attend this award ceremony, guests must be dressed according to the given dress code and they must have valid invitation card. So let's look at our truth table. So let's get P as the guest should wear according to the dress code, Q as the guest has valid invitation. To attend this award ceremony, guest should fulfill these both requirements. That means when the both P and Q is true, the conjunction of P and Q is true. For others, it falls. This is all about logical conjunction. Now Sandini will explain logical implication and biconditional. Sandini, over to you.
Thank you, Rashmi. Now we are going to talk about logical implication. An implication is a type of compound statement that is formed by joining two simple statements with the logical implication, connective or operator. So now let's get an example for that. So here this is John. He's an employee. If he works overtime, he can earn extra money. So there are two conditions. If he works overtime, he can earn extra money. So now we are going to apply these two conditions into a truth table. So I use the first condition as P, an employee works overtime. The second condition as Q, an employee receives extra pay. And this is the logical implication symbol, P implication Q. In the truth table, when P is false, the implication is always true, regardless of the truth value of Q. However, when P is true, the truth value of Q determines the overall truth value of the implication. If Q is true, the implication is going to be true. But if the Q is false, the implication is going to be the false also. So that's how logical implication works. It's important to note that the logical implication does not make any claim about the actual relationship or causality between P and Q in the real world. It deals with the logical relationship between the truth values of the statement. Now we are going to talk about a logical biconditional. A biconditional is a statement that is true if and only if both of its components are true or both of its components are false. It is called an if and only if statement. Simply we can say that a logical biconditional works same as the logical XNOR gate. Let's get an example. And there's a door and it has been locked. So if I have the keys with me, I can open this door. And if I don't have the keys with me, I can't open this door. So let's apply these two conditions into a truth table. The first condition I used as P, the door is locked, and the second condition I put as Q, I have the keys. And this is the logical biconditional symbol, P bicondition Q. In this scenario, the logical biconditional can be interpreted as the door is locked if and only if I have the key. In the first row, we can see when the door is not locked and you don't have the key, the logical biconditional is going to be true. And the second row, we can see that when the door is not locked and you have the keys with you. And here, the logical bicondition is going to be false. The third row, we can see when the door is locked but you don't have the keys. And here also the logical bicondition is going to be false. In the last row, when the door is locked, that means we have the truth value. And you have the keys with you. You also have the truth value. The logical bicondition is going to be true. This means that if the door is locked, you have the key. The door should not be locked. That's how logical biconditional works. Now Rashmi going to talk about the basic laws of algebra.
Basic laws of algebra. The basic laws of algebra are fundamental rules that govern how variables can be manipulated in equations. There are three laws: commutative law, associative law, and distributive law. So let's prove these laws by using truth table. First one is commutative law. The commutative law of addition for two variables is written as a plus b equal to b plus a. In this truth table, all the possible combination of ones and zeros for a and b are included in this truth table. First we fill this a plus b column. 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. Then next we fill this b plus a column. 1 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0. Now you can clearly see this a plus b column is equal to b plus a. That means a plus b equal b plus a. This is the way that how we prove commutative law using truth table. Associative law and distributive law will explain by Sandhini.
Okay, Rashmi. So we can write down the associative law of addition for three variables as a plus within bracket b plus c is equal to within bracket a plus b plus c. So, and also we can use the associative law in multiplication. So this is the expression of associative law in multiplication. So let's draw separate truth tables for these two expressions. In here we have the truth table for the associative law of addition. From these two columns, we can get the right side of our expression. From these two columns, we can get the left side of our expression. We can get the values of a plus b by using the logical OR operator for these two columns. 1 plus 1 is equal to 1, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, 0 plus 0 is equal to 0. Likewise, we can fill this entire column. The same thing we are going to do for this column also, b plus c. 1 plus 1 is equal to 1, 0 plus 1 is equal to 1, 0 plus 0 is equal to 0. Likewise, we can fill this entire column. By adding C into A plus B column with logical OR operator, we can make the right side of our expression. 1 plus 1 is equal to 1, 0 plus 1 is equal to 1, 1 plus 1 is equal to 1, 0 plus 1 is equal to 1. Likewise, we can do the same thing for the left side of our expression also. So when you look at this truth table, you can clearly see these two columns are having same output values. So the associative law of addition is satisfied from this truth table because the right side of our expression are having the same output values as the left side of our expression. This is the expression of associative law of addition. In here we have the truth table for the associative law of multiplication. We can get the value of A and B by multiplying these two columns. 1 multiplied by 1 is equal to 1, 1 multiplied by 0 is equal to 0, 0 multiplied by 0 is equal to 0. Likewise, we can fill this entire column. The same thing we are going to do for the BC column also. 1 multiplied by 1 is equal to 1, 1 multiplied by 0 is equal to 0, 0 multiplied by 0 is equal to 0. Likewise, by multiplying AB column with C, we can get the right side of our expression. 1 multiplied by 1 is equal to 1, 0 multiplied by 1 is equal to 0. Likewise, we can get the we can fill these both columns. So when you look at this truth table, you can clearly see these two columns are having the same output values. So the associative law of multiplication is satisfied from this truth table. Now we are going to talk, this is the expression of associative law of multiplication. Now we are going to talk about distributive law. Distributive law we can written for three variables as follows. So you can distributive law is also a very common law we use for simplify a Boolean expression. In this expression, you can see that b plus c, these two variables are inside in the bracket and a A variable is in outside the bracket. So A have been multiplying with the both of these two variables, B plus C. That's how distributive law works. Let's draw a truth table for this expression. So I have done the same thing as the previous examples. I get the input variables A, B, C and B plus C column by using the logical operator, and A, B and AC columns I use the logical AND operator. And here, when you look at this truth table, you can clearly see these two columns are having the same output values. So both left and the right side of the expression are having same output values. So here we have proved the distributive law using the truth table. And this is the expression for the distributive law. Now Rashmi going to talk about benefits of truth tables.
So let's see what are the benefits of truth table. Truth table provide a clear and organized representation of input-output relationship, and they help to analyze and understand the behavior of logical expression and operations. And also, truth tables serve as a tool for verifying and validating system. Uh, by using truth table, um, the truth table are essential in digital circuit designed for optimizing and simplifying edits. And they aid in decision-making process and problem solving by evaluating different scenarios. Overall, truth tables serve as a powerful tool for understanding, designing, analyzing, and verifying logical function and digital circuit in various domains, including computer science, electrical engineering, and information technology. So now let's try to do some practical questions in truth table. So guys, let's take a minute and read this question. I hope you can see the screen. So in this question, it described about the ways that coffee machine off. The switch of the coffee machine, depends on three inputs: manual switch, watt level, temperature. Let's take manual switch as input A, watt level as input B, temperature as input C, and the coffee machine turn off as F. All the possible combination of zeros and ones for these three inputs are already included in this truth table. Let's do this question. According to this question, the coffee machine turns off only under two conditions. The first condition is the manual switch is turned on and the watt level is below the minimum. So the logic value of the switch is 1 and the logic value of the watt level is 0. Then the coffee machine turn off when A is 1 and B is 0. When A is 1 and B is 0, the coffee machine is turned off. So let's mark it down. And the turning off the coffee machine is represented by the logical value 1. It's given in the question. A is 1 and B is 0. So there are only two instances which the coffee machines turn off under this condition. So the second condition, the manual switch is turned on and the temperature is above the maximum. In this case, the logic value of the temperature sensor is also 1. Then the coffee machine turn off when A is 1 and C is 1. When A is 1 and C is 1, the coffee machine is turned off. Let's mark it down. On the other instance, the coffee machine doesn't turn off. So let's mark them as 0. Now this is the truth table. Now this truth table represents the instance when the coffee machine turns off. Now we take the Boolean expression for this truth table. I'm gonna take SOP expression because it's easy in this case. A FSOP A B bar C bar C bar plus A B bar C plus A B C. This is the SOP expression for this truth table. I hope you guys understand this question. So the next question will explained by Sandini. So let's move on to our presentation.
So as the second question, we have to draw a truth table for this expression. To draw a truth table, first we have to identify the components of this expression. So we can see that there are main two components, A, B bar, that's mean A and B negation, B, C, that's mean B and C. These two components are connected with logical operator. And finally, we have to get the negation of this entire expression. So let's draw a truth table for this Boolean expression. So here I have already added 8 columns with 8 rows. So how we identify the number of rows? In this example, we have 3 input variables A, B and C. The expression is 2 into power 3. So we can have 8 rows in this truth table. So I have added as the columns A, B, C, B negation, that's mean the not operator. In the not operator, we have to replace truth values with 0 and the 0 values with 1. And here A, B bar, that's mean A and B bar, we have to use the logical AND operator. Here BC, that mean here also we have to use logical AND operator. And these two columns are connected here with logical O operator. And finally, we have to get the negation of this entire expression. So how we get the negation? We have to replace truth values with 0 and the 0 values with 1. So we have already drawn the truth table for this Boolean expression. And now let's move on to our presentation slides. So this is the summary of all the things we have discussed in today's presentation. First, we talk about the Boolean algebra, history of Boolean algebra, how construct a truth table, how get a POS expression, how get a SOP expression, and we talk about logical operators in truth tables and the basic laws of algebra. And finally, we discussed some practical questions based on truth tables. So that's how we done our presentation today. And we are moving to the end of today's presentation, and I would like to ask, do you have any problems with regarding our presentation? So I assume that you don't have any questions. And I think that this is the end of our presentation, and thank you for your kind cooperation and have a nice day. Thank you, sir.
Right. Thanks a lot. It's a nice presentation. Just me and Sadhiji, right? Thank you. Very good. Yes. Who are the next team going to do the presentations? Any teams? Any team prepared for?
So group 13.
Group 13 you can get.
All right. We'll go through.
I hope I'm audible. Could someone give me a confirmation?
Yeah, it's audible. Audible and visible, we can. Go ahead.
Okay. So, good afternoon, everyone. On behalf of Group 13, I welcome you to our presentation. So, the topic we're going to be presenting today is 64 architecture. So, let's take a look at what we're going to discuss today. So, first of all, we're going to take a look at a bit of an introduction to 64 architecture. And then we're going to look at how it transitions from 32-bit to 64 architecture. Then we're going to look at the features and advantages it has. Moving on to the advancements and performance optimization it has, and then the memory management and how it parallelly works with 64 architecture. Also, we're going to look at hardware and software support and how it has applied to the real world. Finally, we're going to look at the impact it has made to the emerging technologies. So first of all, if I were to introduce 64 architecture, we have to touch up with a little basics. So first, let's take a look at what a bit in a computer is. So basically, a bit is a digital unit of information, and a bit can take two values. And those two values could represent either 0 or 1, binary as we know it. So in 64 architecture, the processor can handle data and memory that are 64 bits wide. So which means like this can process about 64 bits of data in parallel. So due to this possibility, which this allows like larger memory addressing, increased computational capabilities, and more efficiently handling larger data sets. So in 64 architecture, we use 64 bits. Basically, 64 bits is the width or the size of the data path in processor architecture. So it represents the bits that can be processed or manipulated in a single operation done by the processor. So let's talk a little bit about bit combinations. So bit combinations the formula to get the bit combinations is a very simple one. Basically, it's 2 to the power n. So n here means number of bits. So for example, if you can see here, so like I said, like one bit represents one value, 0 or 1. So if we put 2 to the power 1, we get two combinations, and those two combinations are 0 or 1. Likewise, 2 to the power 2, we get 4 combinations, and those 4 combinations could be 0, 0, 0, 1, 1, 0, or 1. So likewise, so these combinations can also like be told like it represents like how much memory that could be addressed. Like, so say that 2 to the power 32 is how much memory that a 32 architecture system could address. So if we like put 2 to the power 32, if we take that amount in bytes, here it's mentioned in gigabytes, but if we take that amount in bytes, it's about 4 billion bytes. And if we convert it to gigabytes, we get about 4 gigabytes, 4 GB. So in a 32-bit processor, going down further the presentation, you will see that 32-bit processor can address about 4 GB, only up to 4 GB memory space. So that is what we mean by that. And in a 64-bit architecture, what we discuss here, so if you put 2 to the power 64, we get 16 exabytes. So 16 exabytes is basically if we multiply this 4 GB by 4 billion times, then we get 16 exabytes. So 64 architecture can address up to like 16 exabytes of memory. So this is actually like a very large number. We can almost say it's like an infinite number because there isn't a program as of now that addresses up to the one single program that addresses up to 16 exabytes. So this is one advantage which comes to using 64 architecture as well. So next up, like we discussed, we touched up the basics. Now, as we know, like 64 architecture is basically an architecture which introduces 64-bit instruction set, and it allows larger memory addressing and more computational capabilities compared to 32 architecture. And this is also known as x86 64 architecture or AMD 64 as well. So let's take a look at the history of 64 architecture and when it was invented and all. So 64 architecture was developed by AMD and Intel, and that was in the late 1990s. So why do we reinvent something that is already good? Because it has some limitations. That's why we reinvent something. So 32-bit architecture has also been reinvented to a better version called 64 architecture because it has some limitations. And those limitations become the advantages and the features that this 64 architecture has. So compared to the 32-bit architecture, this newly invented 64 architecture has more larger memory capacity and more efficient processing. And the first processor that was invented, first x64 processor in the late 1990s, was named AMD Athlon 64, and it has the compatibility with both 32-bit and 64-bit software. So this compatibility with 32 and 64-bit software, we give a special name to that. We call it the long mode, and I'll discuss that further. So over time, the 32-bit architecture which was used became very less used, and the 64 architecture gained momentum and became widely adapted in the industry. So let's talk a little bit about the transition from 32-bit architecture to the 64-bit architecture we use now. Okay, let's understand first the reason why it shifted from this 32 to 64-bit architecture. So like I've told, the shift happened because it has these new capabilities and new features. So the features are basically it increases memory addressability, it enhances the performance, and also it supports large files and data, it optimizes software, and it has become the new industry standardization. So for example, let's say the 32-bit architecture can address only like 4 GB memory capacity, like I've told before, and a 64-bit architecture can address up to 18.4 million TB of memory. So this 18.4 million is also equal to 16 exabytes, like I've shown in the last previous slides. So due to this, this 64 architecture can facilitate large files and databases. So because of this, the industry has shifted from 32-bit architecture to 64-bit architecture. Now let's compare the memory addressability feature of 32 and 64 architecture. So as you can see here, this here is a hard drive, and this is a memory, and this one is the CPU. So as you all know, when we've done in our past presentations as well, you know how memory management happens. So imagine that there's a program in this hard disk. So how it runs is that it breaks up into parts and it loads into the memory. And from memory, those parts go into the processor, and then the processor processes the program part by part. For example, let's say there's like a 20 GB program, and it breaks down to 5 parts of 4 GB, and then the CPU runs those parts however it chooses. So say that in a 32-bit system, so it breaks down into 4 GB parts. Because the CPU has only 4 GB memory capacity, the ones that are loaded into the RAM can only up to 4 GB parts can run. So say that this 20 GB breaks into 5 parts, only one part from that can be processed, and those rest of the parts, due to this limitation, has to go back to the hard drive. So in 64-bit architecture, this doesn't happen. So from in that hard disk, from that it goes to the memory. Those all of the parts can parallelly run in the 64-bit architecture due to this amazing feature that it has. So let's detailedly compare this 32 and 64 architecture. We discuss about the memory addressability first. So like I told you, like the 32 architecture only has about 4 GB of RAM, and 64 architecture has about 18.4 billion TB of RAM. When we talk about the performance of these architectures, 32 architecture has smaller number of general purpose registers, and 64 architecture has more general purpose registers. So what are general purpose registers? So basically general purpose register is something like that extra registers we have in our processor, so that we could we can use them to address memory or like utilize data at any time. So since 64 architecture has more general purpose registers, it's better for more utilization and performance. And when talking about the software compatibility, since 32-bit is like a bit old now, and nowadays 64 architecture programs are the ones that are being produced, 64 architecture is more compatible with the softwares that are being used. And finally, the industry adoption, predominantly like it was 32 architecture softwares which have been used, but nowadays the standard architecture is the 64 architectures for modern systems. So now let's discuss about the long mode of 64 architecture. So to learn about the long mode, we have to know what a 64-bit x86 processor is. So a 64-bit x86 processor is basically a processor which belongs to the 86 family of processors, and it supports 64-bit computing. So at first 32-bit processors, like if we talk about transition, it started from 16-bit and then it evolved to 32-bit processors. But now, however, due to the advancement in technology, we use x86 transition to 64-bit architecture processors. So this transition introduced a new mode of operation called as a long mode. So long mode is basically where, like theoretically, if I tell you, it's where an operating system can access 64-bit instructions and registers. And like if I give the gist of what a long mode is, it's basically like so 32-bit architecture can't run 64-bit programs, but a 64-bit architecture can run 64-bit programs, and due to this long mode, they can also run 16-bit programs and 32-bit programs as well. So when a computer 64-bit architecture process is running a 32 or 16-bit program, it is running in a mode called the compatibility mode. So basically that is what long mode means. So now to handle the rest of the presentation, I hand it over to Venuja.
So guys, as Shinal explained what 32-bit computing is, I'll give you guys an example to explain the transition from this 32-bit computing to 64-bit computing. So think of a 32-bit computer as a tiny car with limited number of seats, and it can only fit a certain number of passengers at a time. Now imagine the 64-bit computer as a large bus with double or triple the number of seats. So think of an incident where your friends are planning to go on a trip in that small car. Let's think this car has only 4 seats and you have 20 friends. So you might have to make multiple trips back and forth to accommodate everyone, right? Because the car has only 4 seats, but you have 20 friends, and it can be very time consuming and frustrating. But if you use a large bus for this trip, you can fit all your friends in one go, and it will be very efficient, time saving, and also a comfortable experience for everyone. So in the world of computing, this transition from the 32-bit computer to a 64-bit computer was like moving from a small car to a large bus. It had larger data processing, smooth multitasking, and it was a better, enjoyable experience for everyone. So it was moving from something like this to this. So let's discuss about features and advantages of this x64 architecture. Why this x64 architecture is so special. One of the main advantages is its increased memory addressing capacity. So imagine a world where where your computer has all the memory it needs. Well, with 64-bit computers, it has become a reality. So you can just, so it will support any extensive memory configuration or memory intensive application. Another main advantage is its enhanced performance. So with wider registers and increased number of general purpose registers, it has enabled more efficient data processing and reduced memory access. So another main advantage is its compatibility with 32-bit software. So you don't have to worry whether your old software or applications won't run in these 64-bit systems, because they will. The main reason is it has backward compatibility, and you don't even need any modifications or upgrades to do this because of this backward compatibility. So x64 computers are also incorporated with high security features such as data execution prevention and ASLR, and we will discuss these terms later in the slides. So 64-bit computers are also supported by major operating systems in the world right now, such as Windows, Mac OS, and Linux. Software developers have the luxury to use any development tool or device drivers they need. So 64-bit computers also provides a solid foundation for future developments such as AI and machine learning. So let's discuss about the advancements and future trends of this x64 architecture. So what are the companies such as Intel and AMD focus on in order to improve this 64-bit computing even more? So one of the main areas they focus on is increasing the core count. So whether you are a scientist, a gamer, or even some professional working with a daily task, if you have more processor cores in your computer, the smoother the performance will be, the better the performance will be. This will also help in multitasking. Another trend they focus on is improving the energy efficiency even more. So the future x64 computers will not only be powerful, but they will also be environmental friendly. And these are mainly done by advanced power management techniques and optimized designs. So these will provide less energy, which will help to maintain the carbon footprint as well. So as we all know, one of the main threats in the world right now is cyber threats, and they increase day by day. And so these companies focus on improving the security features even more. So they will integrate various features such as hardware level security and encryption algorithms in order to protect our computers from malwares and unauthorized access. So let's discuss about the future of computing. Whether it is AI, machine learning, or any other mind-blowing technology we don't even know yet, they all of them will be supported by these 64-bit computers. So they will be equipped with specialized designs and dedicated accelerators in order to improve the performance of these AI work in the future. So they will provide a great foundation for the future innovations in the world. So these future x64 architectures will also be incorporated with large and fast caches. So it will enhance the memory even more. And they will also be incorporated with new emerging technologies. So let's discuss about performance optimization. So what is performance optimization? So these are the modifications done to the system in order to make it more efficient and effective. So one of the main topics that come under performance optimization is instruction level parallelism, which I'll refer to as ILP during the slides. So what is ILP? It is the ability of a processor to execute multiple instructions in parallel, thereby increasing the performance of the computer. So ILP can be achieved in various techniques such as pipelining and superscale execution. So we discussed about pipelining during OS as well, but I'll give a small idea about it again. So pipelining allows multiple instructions in different stages of the execution cycle to run. So we all know what fetch execute cycle is. That is the fetch decode execute cycle that happens in the processor. So in pipelining, it overlaps multiple instructions in different stages of this cycle. So let's discuss about the fetch decode execute cycle for a bit. So in the fetch stage, the control unit in the processor retrieves an instruction from the memory that needs to be executed. And in the decode stage, this fetched instruction will be decoded into operation and operand. And in the execute stage, this instruction will be executed in the ALU. And the output will be stored back again in the main memory. So in traditional CPUs, like before 64-bit computers, the stages of the cycle are executed as a sequence of instructions. So as you can see, instruction 2 was executed after instruction 1 was already executed, and instruction 3 was executed after all of them were executed after. So it takes a lot of time. But in modern processors after 64-bit computing, this fetch decode execute cycle was pipelined. So multiple instructions can be in different stages of the cycle at the same time. So as you can see, instruction 2 is fetched when instruction 1 was in decode stage, and instruction 3 was fetched when instruction 2 was in the decode stage and instruction 1 was in the execute stage. So the time is saved here, and also it has helped to improve the efficiency of the computers. So another technique that comes on ILP is superscale execution. So this takes ILP a step further by enabling the processor to issue multiple instructions per clock cycle. It leverages multiple execution units within the processor to execute multiple independent instructions concurrently. Another technical term that comes on the ILP is out-of-order execution. So this is a technique employed in x64 processors to maximize instruction level parallelism by reordering the execution of instructions dynamically. So what is this difference between ILP and out-of-order execution? In ILP, it's all about executing multiple instructions at the same time. But in out-of-order execution, it dynamically rearranges the order of instruction. So these are executed out of their original sequential order. So another topic that comes under performance optimization is cache hierarchy in x64 architecture. So we all know what cache memory is, right? It is a small high-speed memory that stores frequently accessed data in our computer, and this acts as a buffer between the CPU and the main memory. So when talking about the cache hierarchy, it typically consists of 3 levels: level 1 cache, level 2 cache, and level 3 cache. Level 1 cache is the smallest and the fastest, while level 3 cache is the slowest and the largest one. So level 1 cache, as we can see, is the closest to the CPU. Level 3, as we can see, is the furthest away from the CPU. So the table represents the difference between level 1, level 2, and level 3 caches. And we discussed about these things earlier. So level 1 cache is also known as primary cache. Level 2 is also known as secondary. Level 3 is known as external cache. So when discussing about cache and cache optimization, so when discussing about cache optimization is another technique we have to use. So this is this refers to a set of instructions aimed at improving the performance of cache memory. So the main goal is to maximize the cache utilization, as cache performance has a significant impact on overall system performance. So better the cache utilization and cache performance is, better our system performance is. So types of cache optimization are cache line alignment, prefetching, spatial locality optimization, and temporal locality optimization. So we'll have a small summary about this. Prefetching is a technique anticipated future memory accesses, and they fetch data into the cache before it is actually needed. So this is mainly done using various hardware and software mechanisms. Cache line alignment refers to the practice of aligning data structures and memory accesses with the cache line size. So what is cache line? So what are cache lines? So they are small units of data that can be fetched from the cache. Spatial locality optimization. So this is a technique that focuses on organizing data in a way that maximizes cache hits, while temporal locality optimization means it aims to reuse recently accessed data. And this is done by keeping frequently used data in the cache for as long as possible. So branch prediction is another technical term that comes under performance optimization. So this is a technique that is used in computer processors to guess the outcome of branches in a program code. So what are branches in a program code? So these are instructions that determine the flow of execution based on certain conditions. So for example, an if statement in a program may have two branches. One branch to be executed if the condition is true, and another branch to be executed if the condition is false. So branch prediction have two types, mainly static and dynamic. So in static branch prediction, it assumes a fixed outcome for all the branches. So this approach is based on observation that certain branches in the code have predictable behavior. And in dynamic, it uses runtime information to make predictions about branch outcomes. And this relies on historical branch behavior to predict future outcomes. So, dynamic branch prediction consists of two main types, which are known as branch target buffer and branch history table. So in order to talk about memory management and other topics, I'll invite Min Sarat to the presentation.
Thank you, Venkat. So guys, I'm going to talk about memory management related to this part. So, paging structures in x64 architecture. First, I want to explain how paging structures and the x64 architecture work together to manage virtual memory and provide a large address space. The x64 architecture is an upgraded version of the x86 architecture. It supports 64-bit addressing, which means it can access a much larger address space than before. To manage virtual memory, we use paging structures that organize and map virtual addresses to physical addresses. Normally, we know there were three levels of page maps: the page directory, and the page table. We have an additional level called level 4 page map table, or PML4. So, paging structures in the x64 architecture help to manage virtual memory and provide a larger address space. So guys, I'm going to talk about page tables. Firstly, this is the basic unit of the paging structures. Page table is a data structure that maps virtual addresses to physical addresses. Then we are going to talk about page directory. This is a higher level structure that contains pointers to page tables. This executes as an intermediate level between the page tables and the virtual addresses. Then we can see page directory pointer table. The page directory pointer table is the next level of the paging structure. This contains pointers to page directories. Now we already discussed there is a additional level can be seen here in x64 architecture, that is a page map level 4 table. It contains pointers to page directory pointer tables. So now you can see this picture. So all the levels of page maps can be seen here in this picture. Page table, page directory, and page directory pointer table, page map level 4 table. So now I'm going to talk about virtual memory addressing. Virtual memory addressing programs use virtual addresses as labels for memory locations they want to access. Virtual addresses provide a way to talk about memory without worrying about its actual location. This translation process, when a program uses a virtual address, the system converts it to a real physical address where the data is stored. The system uses tables to keep track of the mapping between virtual and physical addresses. So, in this picture, we can see how it is working. So the system divides memory into fixed size chunks called pages. This is a page, and each page has a unique number assigned to it. This is a page number. This is a unique number to each page. When a program gives a virtual address, the system checks the tables to find the corresponding page number. I think you got it. And once the page number is found, the system combines it with the offset within the page to get actual physical address. This is the physical address. We can call it as a frame. The physical address tells system where the data is stored in the real memory. This is the memory. So now we are going to talk about a large page support and super pages. Large page support and super pages are management techniques that improve the performance by large memory chunks. So large page support. In virtual memory, memory is divided into small fixed size pages. Large page support uses bigger pages instead of the standard small pages. Large page support, the bigger pages mean like 2 megabyte or 4 megabyte. And small pages mean like 4 kilobytes. With larger pages, the system needs fewer entries in its memory management tables. And these help to reduce the work needed to manage memory and improves performance. Then we are moving to super pages. Super pages are even bigger than larger pages. Super pages further reduce the number of entries in memory management tables. And they also help the system store and access large memory regions more efficiently. By using super pages, the system can speed up memory access and improve performance. Okay, memory protection mechanisms. In x64 architecture, memory protection mechanisms are employed to ensure the security and integrity of the system's memory. The purpose of these mechanisms is to prevent unauthorized access, modification, or execution of memory regions. So there are 4 memory mechanisms, key memory protection mechanisms can be seen, and they are address space layout randomization, ASLR, data execution prevention, DEP, non-execute bit, and virtual memory. So I'm going to give a short description about all of these mechanisms one by one. Virtual memory. Virtual memory can also be used memory protection mechanism. It allows the operating system to provide each process with its own virtual address space. Address space layout randomization. ASLR is a technique that adds an additional layer of security by randomizing the memory layout of a process. And next, data execution prevention, DEP. DEP is a security feature that prevents the execution of code in certain memory regions that should only contain data. And non-execute or execute disable bit. This is a NX, we can call it NX. NX is a hardware feature supported by x64 processors that works in a conjunction with DEP. So guys, let's talk about the real world applications of this x64 architecture. First and foremost, x64 architecture is the driving force behind desktop and laptop computers, forming the foundation for operating systems, applications.
Excuse me.
Yes, sir.
Yeah, Buddha, anything else that you have to tell except the text in the screen? That would be great because we can read the stuff because I have gone through up to now. It's just going through the slides as it is. We can
Okay.
read it. Thanks. Anything else if you have, you can tell us.
Okay, sir. Sorry, sir. So, when we are talking about desktop and laptop computers, whether you are browsing the internet, editing documents, or running complex software, chances are you are benefiting from the power and versatility of x64 architecture. And beyond personal computing, x64 architecture plays a vital role in server and data center environments. Its scalability, performance, and compatibility make it a preferred choice for hosting virtualization, cloud computing, and big data applications. And the robustness of x64 architecture allows businesses to efficiently manage their data, handle a high volume of traffic, and deliver reliable services to users worldwide. So, high performance computing. In the realm of high performance computing, x64 architecture reigns supreme. This empowers scientific simulations, computational modeling, weather forecasting, and other computationally intensive tasks. The immense processing power and efficiency of x64 architecture enable researchers and scientists and engineers to tackle complex problems and make groundbreaking discoveries. Even the world of gaming, when we talk about gaming consoles, even the world of gaming has embraced the capabilities of x64 architecture, leading gaming consoles like PlayStation 4 and Xbox One utilize x64 architecture to deliver immersive gaming experiences and handle the demanding graphics processing required by modern video games. This architecture ensures that gamers can enjoy visually stunning worlds and realistic physics and seamless gameplay. Additionally, x64 architecture plays a critical role in virtualization and containerization technologies. These technologies enable efficient resource sharing, isolation, and management of virtual machines and containers. And thanks to x64 architecture, businesses can consolidate their infrastructure, reduce costs, and enhance the flexibility and scalability of their IT systems. So in conclusion, the real world applications of x64 architecture are vast and profound, from powering our desktop and laptop computers to enabling high-performance computing, hosting virtualization, containerization, and revolutionizing the gaming industry. x64 architecture has truly transformed the way we live, work, and play. Its scalability, performance, and compatibility continue to drive innovation and shape the future of computing. So, first and foremost, let's discuss operating system. Sorry, I'm going to talk about software and hardware support. So, let's discuss operating systems. Windows, developed by Microsoft, you all know, offers extensive support for 64-bit architecture. Windows XP Professional x64 edition and subsequent versions, including Windows 7, Windows 8, Windows 10, and Windows Server editions, have all embraced 64-bit capabilities. Moving on to Mac OS, the operating system designed by Apple for their Mac computers. It has been supporting 64-bit architecture since Mac OS X 10.4 Tiger. Apple has even transitioned their Mac lineup from Intel-based processors to their own ARM-based Apple Silicon, ensuring full compatibility with 64-bit architecture. Linux. The popular open source operating system kernel has long been a supporter for 64-bit architecture. Linux distributions such as Ubuntu, Fedora, Debian, and many others offer dedicated 64-bit releases, empowering users with the advantages of x64. Now let's shift our focus to development tools. Microsoft Visual Studio, a widely used integrated development environment, provides developers with a powerful platform for creating applications targeting x64 architecture. With its extensive set of tools, compilers, and debugging capabilities, Visual Studio enables efficient development for 64-bit systems. Another notable tool is GCC, that means GNU Compiler Collection, a free and widely adopted compiler collection. GCC supports x64 architecture and offers compilers for various programming languages like C, C++, and Fortran. So now we are going to talk about Intel Parallel Studio. It is a suite of development tools from Intel. It's specifically designed to optimize applications for x64 architecture. It includes compilers, performance analyzers, and libraries that enhance the capabilities of x64 processors. Additionally, LLVM, low-level virtual machine, an open source compiler that infrastructure supports multiple programming languages and architectures, including x64. Its flexible framework for code generation and optimization empowers developers to harness the potential of x64 architecture. So, lastly, let's touch upon device drivers. The Windows Driver Kit, WDK, provided by Microsoft, equips developers with the necessary tools and documentation to create device drivers for Windows operating systems supporting x64 architecture. On the now when we are talking about Linux kernel, on the Linux front, the itself includes built-in support for x64 architecture and offers a wide range of device driver for different hardware components. Many drivers are either part of the kernel source code or available as loadable kernel modules. Furthermore, hardware manufacturers often provide driver development kits specific to their devices or platforms. These kits offer development tools, sample code, and documentation to assist in creating device drivers that are compatible with x64 architecture. Additionally, some vendors offer software development kits that cater to their specific hardware components or platforms. These SDKs provide libraries, APIs, and tools for developing device drivers that ensure seamless integration with x64 architecture. So now I'm going to hand over this presentation to Shenal.
Thank you, Minsarat. So now we're going to talk about the impact that 64 architecture has had on new emerging technologies. So first, let's talk about AI. So we all know what AI is, and so when developing AI applications, these models which are very complex, 64 architecture plays a very crucial role, and the computational resources needed for training these complex AI models is provided by 64 architecture, mostly because of its support for parallel processing and memory capacity. It enables to execute AI algorithms and other advancements like machine learning, deep learning efficiently. So next up, we're going to talk about Internet of Things. So if I explain what Internet of Things is, basically a device with a sensor which gathers data is called basically an Internet of Things device. For example, let's say like an AC we operate through a phone or like a traffic light. So those things have sensors, and through those sensors they gather data and they send it back to their manufacturers, which helps them to build up the faults that those devices have and like gather other information to increase like the productivity of the device or the efficiency of the device. So that is called Internet of Things. So when these things gather data from sensors, all of these things, like there are like a lot of IoT devices surrounded by us, all of these things send it to one server, and from that server it goes to their manufacturers. So in order for this process to happen efficiently and without any block, 64 architecture plays a good role. And next we talk about high performance computing. Minsara has also discussed about high performance computing. So when it comes to 64 architecture and high performance computing systems, it is very important that a smooth flow has to be there to for simulate research and do like scientific large scale data analysis, especially in fields like weather forecasting and genomics. 64 architecture comes in very useful hand. And next up is the blockchain and cryptocurrency. I'm sure all of us knows what cryptocurrency is. For example, let's say like the trending cryptocurrencies nowadays are like first up is Bitcoin, and there's like Ether and Dogecoin, stuff like that. And blockchain is basically the technology which provides the architecture to the cryptocurrency. So when a transaction happens, say that I have like 5 cryptocurrencies and another person has one, and if I give him one cryptocurrency, that transaction is recorded in what we call a block. So at that instances, when we transfer cryptocurrencies, how much cryptocurrencies we have is recorded in something called a block. And those and all the transactions happening in cryptocurrencies are made through this chain of blocks. So that is what we call blockchain. And due to this, banks, like intermediaries, banks don't have to come in hand of trading cryptocurrency. So that is basically the use of blockchain. And also, like, to support blockchain networks and cryptocurrency mining, the advantages of 64 architecture comes in a very useful manner. So let's take a look at what we covered so far. So first we discussed what 64 architecture is. Then we went on to learn about the history of 64 architecture. And then we talked about how it transitioned from 32-bit to 64 architecture. And then again, the advantages of it, how it optimizes performances, then advancements and future trends of 64 architecture. And then we talked about how memory management parallelly works with 64 architecture. Next, hardware and software support. And then how we talked about the real world applications of 64 architecture. And finally, we talked about the impact it has on new emerging technologies. So that is the end of our presentation. Is there any questions? So I'm assuming there aren't any questions. So thank you very much for your time. And also I'd like to apologize because we couldn't turn on our cameras, and if we turn on our cameras, a connection issue happens and the presentation lagged. So that's the reason we couldn't turn it on. So we're very sorry for that. Thank you for your time.
Right. Okay. Actually, something to learn, guys, for everyone. Please don't read the slide as it is. It's something that not good for the presenter. Always tell, keep it as a point for reader, and make sure to interpret it, clear it to the audience. That makes sense. Right? Something to add to enhance your lives. Up to now, I haven't encountered such serious cases. Some of students like gone here and there, but this time it was a bit serious. Nearly almost all the slides gone, similar to that. I mean, some of parts. Right? So to don't encounter that problem again. Somehow I think it was because of the time limitation. Within a couple of days, it was prepared altogether. Somehow done something. That's good. Appreciate it. All right, we'll go to the next presentation. Yes, Naveen, go ahead. Yeah, team, what has happened? We can't hear, we can't see. Is there a technical problem from my end or common for all? Yeah, Naveen. I think the network issue is in there. You could switch off your camera, then probably the problem solved, because the bandwidth consumption we can save by switch off the camera. Because for the process images, it takes much more computational resources. So we can switch off the camera and proceed. You can share your screen and switch off your camera.
I hope everyone is doing great after two presentations.
All right, now it's good. Yes.
Sure. Can you see the screen?
Yep, we can see.
So today we are going to speak about input and output techniques. Before the start the presentation, let me introduce my fellow team members. Bhavindran. So, Bhavindran,
You don't know the other team member who worked with you. Huh?
Bhavindran Prageet Harshan with me. So it will be little bit confusing because last week also we had the presentation similar named by group 11 fellows. This week we going to talk about not those topics but related to input output techniques. Moving on to next slide, let's see what we are going to talk to. We are going to speak about I/O interfaces, I/O controllers, caching and I/O performance, I/O virtualization, storage systems and I/O, network I/O, and finally any questions from you. So, what is an I/O process and what is an I/O techniques? Let's simply think about how our computers work. Our computers work by getting inputs from us through the input devices and do some computational things inside the computer and process inside the processor, and then give some outputs through output devices. That is how our computers work. It means input output process, we can say it is the communication between computer and its external environment. It involves data transfer between input devices and computer, and data transfer between computer and output devices. Then we can see here, without input output process we can't have any compute system, because it is the most basic function of a compute system. Without input output process we can't have any compute system. So let's move on to computer input output techniques. Input output techniques means how do we do the input output process, how do we handle input output process. Last week group 11 fellows talked about some input output techniques like programmed IO, interrupt driven IO, direct memory access IO, etc. So moving on to next slide, I would like to talk about the input output architecture. As you can see here, the processor, cache memory, and the main memory. The processor and cache memory connected through the buses, and main memory and cache memory connected through the memory IO interconnect. Memory IO interconnect means simply how memory and input devices connected. Usually, memory IO interconnect connected. Memory IO interconnect means the communication pathway between main memory and IO devices. Usually, the buses are the memory IO interconnect. Then we can see here IO controllers and some input and output devices connected to IO controllers. IO controllers connected to also the memory IO interconnected. Then we can see here interrupts. Yes, interrupts means how input devices get access to the processor. When if IO device want to access to the processor, they send interrupts. If processor accept the interrupt, it means processor will interrupt the current executing task and save it and give the processing time to the input device. Then after that, again processor will do the previous task. That is how input output process works. So moving on to next slide, we are going to talk about I/O interfaces. Pragit will be continue from here. Over to you, Pragit.
Thank you, Naveen. Today I will be talking about input-output interfaces. Then, what is an input-output interface? Input-output interface is not just a software component or just a hardware component. It is a combination of hardware and software components, and that allows transferring information between external input-output devices. Now, let's move to the next slide. Let's start by discussing the two main types of input-output interfaces. First one is parallel interface and second one is serial interface. A parallel interface transfers multiple bits of data simultaneously over multiple data lines. This means that several bits are sent at once, allowing for faster data transfer. The data transfer is speed determined by the number of parallel paths. You will get a better understanding from the image under the parallel interface. In this image, there is a sender and there is receiver. As you can see, there are multiple channels between sender and receiver. Now, let's move on to the serial interface. A serial interface transfers data one bit at a time over a single data line. Serial interfaces send data sequentially, one after another. In this picture, there is a sender, there is a receiver, and there is one data line between sender and receiver. Now, let's move to the next slide. Here, parallel interface. I will explain about parallel interface furthermore. First, characteristics of parallel interfaces. First one is multiple data lines. I already explained about multiple data lines in previous slide. The second one is high-speed data transfer. Parallel interface use multiple data lines for data transmission and several data sent at once. So data transfer speed of parallel interface is high. The data transfer speed is determined by the number of parallel paths and the number of bits processed at a unit time. The third character is limited cable length. As the cable length increases, there is a risk of crosstalk. Let me explain crosstalk. Crosstalk is the coupling or interference of signals between two or more data lines. Then again, third character, limited cable length. As the cable length increases, there is a risk of crosstalk, which leads to interference and unsuccessful data exchange. Therefore, the length of the cable cannot be increased beyond a certain safe limit. Then examples for parallel interfaces. First one is ISA, second one is PCI. Now let's move to the next slide. Here, in serial interfaces, transmits data as a series of voltage pulses over wire. One is represented by a high logical voltage and 0 is represented by a low logical voltage. Here data is 1, 0, 1, 0, 0, 0, 1, 0. Then first bit is 1, then voltage of signal is high. As you can see in this picture. Then second one is 0, then voltage is low. again next bit is 1, voltage is high. Others are like that. Here we can clearly understand voltage pulses in serial interface from this series of voltage pulses. Then next, I will explain about serial interfaces furthermore. First, characteristic of serial interfaces. First one is one data line. Second one is serial transmission. Third one is lone cable length. As the lone cable length increases, there is a not risk of cost drop. Therefore, the length of the cable can be increased. Example, USB, it's mean universal serial bus, and SATA, serial LATA, and Thunderbolt. These are examples for serial interfaces. Now, let's move to the next slide. Here, comparison of different interface. Parallel data transfer involves sending multiple bits simultaneously. This method enables faster data transmission. On the other hand, serial data transfer involves sending data bit by bit, with each bit following the previous one. So this method has slower transmission. Then moving on to cable length, in the parallel interface, there is a risk of crosstalk. So cable length of this interface usually is short, but in the serial interface, there is not a risk of crosstalk. So cable length of serial interface usually is long. Another important difference is power delivery. In parallel data transfer, the cables transfer only data. In serial data transfer, the cables not only transfer data, but also provide power to connected devices. Then lastly, we come to the utility of these data transfer method in modern systems. Parallel interfaces are rarely used in modern systems, and serial interfaces are widely used in modern systems. Then next topic is input-output controllers. This topic will be continued by Bamidu.
Thank you, Pragit. Here, as you can see on the screen, I will discuss about I/O controllers. I want to highlight here the importance of an often overlooked yet indispensable component in I/O computer systems, the input-output controller. These hardware devices plays a crucial role in enabling seamless data transfer between input-output devices and central processing unit of a computer. The I/O controller serves as a vital link between CPU and external devices such as keyboards, mice, printers, monitors, and storage devices. It acts as a facilitator, ensuring that data can flow smoothly between these devices and the CPU. Think of the I/O controller as a bridge, translating the different data formats used by various input-output devices into a standardized language that the CPU can understand. It harmonizes the diverse methods of a data transmission, allowing the CPU to process information effectively. Let's move to the next slide. That the functions of I/O controllers. The input-output controllers perform a variety of functions: data buffering, error detection, interrupt handling, and device control. Data buffering. Input-output controllers buffer data between the CPU and peripheral devices. This helps to improve performance by reducing the number of times the CPU has to access the peripheral devices directly. Error detection. Interrupt handling. Input-output controllers can handle interrupts from peripheral devices. This allows the CPU to be notified when an event occurs at a peripheral devices such as a key press or discrete data buffering. And as previously I mentioned, data buffering data buffering, input output controllers buffer data between CPU and peripheral devices. This helps to improve performance by reducing the number of times CPU has to access the peripheral devices directly. And device control. Input output controllers can control the operation of peripheral devices. This includes tasks such as configuring the devices, setting its parameters, and starting and stopping it. And also there's another function of input output controllers, and interrupt handling. Input output controllers can handle and interrupts from peripheral devices. This allows CPU to be notified when an event occurs at peripheral devices, such as key press or a discrete. And next I like to move the two main types of I/O controller architectures. There are, as you can see on the slide, there are two types of input-output controller architectures. The first one is direct memory access. Direct memory access controllers use direct memory access to transfer data between CPU and peripheral devices. DMA allows to CPU to continue processing data while the input-output controller is transferring data. And the other one is interrupt-driven controllers. Interrupt-driven controllers use interrupts to transfer data between the CPU and peripheral devices. The CPU must stop processing data to handle the interrupt. Here, you can see data transfer protocols and bus architectures. There are a variety of data transfer protocols and bus architectures used by input-output controllers. Parallel communication. Parallel communication uses a single data line to transfer data between CPU and peripheral devices. Parallel communication is typically used for high-speed data transfer. Another one is serial communication. Serial communication uses multiple data lines to transfer data between CPU and peripheral devices. Serial communication is typically used for low speed data transfer. Also, guys, data transfer protocol.
Yeah.
Sir?
Hold on.
Yes, sir?
Yeah, hold on, please. I think it should be changed, right? Serial communication is the first one, and second one is parallel communication, right?
Okay, sir.
It's multiple lines for parallel. Serial is single line.
Okay, sir.
Once you are sharing the slides, please update it properly.
Okay, sir.
All right.
And then data transfer protocols serves as a foundation for transmitting data between devices and systems. They define the rules and procedures for data exchange, ensuring that information flows accurately and efficiently. These protocols establish a common language that allows diverse devices to communicate effectively, regardless of their underlying hardware or software. In addition to protocols, bus architecture are essential components in computer systems. A bus refers to a communication pathway that connect various hardware components such as processors, memory modules, and input-output devices. It serves as a conduit for data transfer, allowing different parts of the system to exchange information. Next, I invite to Naveen to caching and to discuss about caching and input-output performance. Over to you, Naveen.
Thank you, Bhavindu. Caching and I/O performance. I think you have listened many presentations and also the OS lesson about caching. Last week also we had a presentation about caching by Mihan, and also today you learned something about caching from our group 13 fellows. So let's talk about what is a cache. Cache is a small but fast memory. It stores copy of recently accessed data. Usually cache memories are located inside the CPU or near to it. Cache memories are very expensive, but it has a very small amount of storage size. Move on to the next slide. Let's discuss why do we use cache memories. During the recent performance upgrades in CPU, but main memory isn't got upgraded in that level because main memory don't have such speed than CPU. So because of that there is a bottleneck. Bottleneck means we can't take the full efficient. We can't the full. We can't use the full performance due to this problem. So therefore the problem is the data transfer between CPU and the main memory is slower. So that problem solution for that problem is the cache memory. Using cache memory we can increase the data transfer speed. And another reason is we use cache memories or reduce the traffic on system bus. If we use main memory and the CPU to transfer data, there is a more traffic in system bus than using cache memory and CPU. And also cache memory is more energy efficient than main memory. Moving into next slide, I would like to speak about considerations about cache memories. Consideration about cache memory means what we should consider about the when we talk about function of cache memories. We have to think what and when to put data into cache memory and what and when to throw out some data from cache memory, because cache memory has limited space. We have to clarify what to put and what to throw out from cache memory. Without that we can't use cache memory efficiently, and we have to think how to keep cache memory sync with other caches in the different processors. And also we have to think the size of cache memory and how many items for cache memory for the full efficiency. Moving on to the next slide, I would like to speak about caching principles. Caching principles come to the scene is when we have to deal with previous considerations about how should cache work. Then caching principle come to the scene. There are two main caching principles: locality reference and management heuristics. Let's dive deep into those caching principles. Locality of reference means the tendency of processor access the same data memory locations. There are basically two types of locality of references. First one is locality of time, or another words, temporal locality. It means CPU will use the same data again and again short period of time. In another type of locality of reference is spatial locality. It means data is stored in nearby to the current executing data have high chance of the executing next. The difference between temporal locality and spatial locality is, in temporal locality, it is using same data again and again in a short period of time. In spatial locality, it is the tendency to use the data nearby to the current executing data. So using these locality references, cache memory can take into the data which needed to process next time. The second one in the caching principle is management heuristics. Management heuristics means management instructions. How the cache memory manages content and how cache memory manage the consistency between different level of caches and the caches in different processors. Management heuristics are implemented in cache controller. It serves as a interface between CPU and the cache memory. Moving on to next slide. Content management heuristics. Content management heuristics are the set of rules that determine what and when to put and out to the cache. Content management heuristics then do two tasks basically: copying data into cache and evicting data from cache. There are several ways to copying data into cache memory. First one is cache line filling. It means if processor needs some data, first time processor check in the cache memory. But if processor can't find the data in cache memory, processor will find data in main memory. So when bringing main memory data from main memory, it will also bring that data to cache memory first. That is the cache line filling. And presentation also, it is the using the locality reference, the cache will bring related data to cache memory before needed to process it. Then other thing is evicting policy. It means how what and the when you should remove data from cache memory. There are several algorithms to determine what and when the data should remove from the cache memory. First one is least recently used. By this algorithm, cache memory will remove data that not least recently used. So not recently used. It means cache memory will remove and first in first out algorithms. Cache memory will remove the first came data first, and least frequently used algorithm, cache memory will remove the not the data that frequently used. Moving on to next slide. The second part of content management heuristics are consistency management. In other words, is we can say coherence. Consistent management is the managing the data in cache memories synchronized and consistent in different level of memory hierarchies and different level and other processors. In it also need to caches to prevent having multiple copies of data, because if have multiple copies of same data, it will cause to error. When then if you have to manage the consistency, we have to do write through and write back policies. It means if first we get some data to cache memory and that data has changed during the processing, so then there is a changes between some level of caches and memories. So we have to, if we want to maintain the coherence, we have to do something about the differences in the same data in different level of memories. So we have to maintain the consistency. We have two policies to do that. When using write true policy, the all the memory hierarchies will be corrected to the newly added data. Then it will be actually little bit time consuming because they need to correct in the same time. And in other hand, write back policy use basically firstly data will be updated in the level 1 cache, and during the processing time other levels and main memory will be updated. That type not get long processing time, that is actually very speed than write through policy. Moving on to next slide, I would like to speak about benefits of caching IO operations. There are several benefits of caching. Caching will improve the performance of computer system because retrieve data from main memory. So that will be caused to slower the computer system. And cache memory also reduce the latency. And cache memory will help to reduce the load on original source, because cache memory will free fetch data to cache memory. We don't need to go for the original data again and again. We can use copied data in processing. And also cache memory will help to for saving some codes rather than going for expensive hardware and infrastructure updates. Moving on to next slide, I would like to talk about different type of caches. Until now, we only talk about CPU cache, but there are many different type of caches: buffer cache, disk cache, browser cache, and so on. Then I will talk about buffer cache and disk cache. Buffer cache is actually in the main memory. It stores some data from other storage devices in the main memory. Then it will helps to reduce the latency rather than retrieving data from storage devices. In buffer cache will keep data until it no longer needs. In other hand, disk cache means in disk cache, hard disk and SSDs will have a copy of recently accessed data in disk itself. It will helps to reduce the searching time of the data in large space area, storage area. Then trade-off between caching, latency, and consistency. Because we have very limited storage on caching, and caching is very expensive. We have to trade off. Latency is the time to take processor request. If latency is lower, it means we have faster processing speed. It means lower latency means the better performance and better user experience. In other hand, data consistency means as you can said previously, managing the same data during different memory hierarchies. If we increase cache, we can reduce the latency, but we can't increase data consistency, because if we increase cache memory, if we have to manage data consistency, it will be very slow. Moving on to next slide. Next, I will like to talk about IO virtualization. IO virtualization is we have learned about actually virtualization. Virtualization is originally coined by Popek and Goldberg, an efficient and isolated duplicate of efficient and isolated duplicate of real computer machine. So in virtual machines, we need also virtual IO device, virtual IO devices and other IO related things. So IO virtualization is using physical devices to in IO in virtual machines. It creates virtual IO devices that map to the physical IO devices. Device drivers and their role in virtualized environments. Device drivers in virtual environments are implemented as software drivers. It means the software components emulate the behavior of hardware devices. Then they allow virtual machines to access the physical hardware devices. Different type of virtual devices: network drivers, storage device drivers, graphic drivers. Normally these are the physical drivers. Then when it comes to virtual device drivers, these will be act as also virtual device drivers. Moving on to next slide, I would like to talk about IO virtualization techniques. There are two main IO virtualization techniques. One is para-virtualization. It requires IO devices drivers to modify to support IO virtualization. And hyper-based virtualization means IO device drivers doesn't need to modify. In this, we can see this. The software only means IO drivers will working with the hypervisor, and hypervisor will the communicate between IO devices. In the right hand pick diagram, we can see the IO devices will directly IO drivers will directly communicate with IO devices. That is the difference between them. One left side one is working with hypervisor, and hypervisor will communicate with the IO device. The right hand side one will directly communicate with IO device. We can have challenges in IO virtualization. First one is performance issues. IO virtualization can have performance increases and also performance issues if we use emulation, it will cause to performance issues. And also if program is very sensitive to latency, and there is also a latency issue in virtualized IOs, and there is a complexity issue on implement and managing IO virtualization, and there are some compatibility issues in device drivers because every device driver won't be support to the IO virtualization. And also we have security issues in virtualized environments and virtual machines. That security issues will be also affect to these IO virtualizations, such as one virtual machine gaining access to another virtual machine's data or physical data. Moving on to next slide, Bhavin will talk about storage systems and IO. Over to you, Bhavin.
Thank you, Navin. Here I will be discussing about storage systems and input-output. Storage systems are foundation of our computer systems. They allow us to store and find data quickly. We use different technologies like hard drives, solid-state drives, and tape drives for these purpose. Each technology has its own advantages and uses. Disk I/O operations, and let's move to the next slide. And disk I/O operations are the basic unit of work performed by a storage system. They can be classified into two types: reads and writes. Reads performed when data is retrieved from a storage system. Writes are performed when data is stored to a storage system. Then, disk I/O operations have a number of characteristics that can affect their performance. Some of them are bandwidth. Bandwidth is maximum amount of data that disk can transfer in a given amount of time. Latency. Latency is the time it takes for disk to complete an input-output operation. IOPS stands for input-output operation per second. It is measure of how many read and writes operation a disk can perform in a given amount of time. Solid-state drives have a significant impact on input-output performance. SSDs are much faster than traditional hard disk drives because they do not have any moving parts. And this means SSDs can access data much more quickly, which can lead to significant performance improvement in variety of applications. And some of the specific ways in which SSDs can improve input-output performance. Reduce latency. SSDs have a moving part, so they can access data much faster than hard disk drives. This is especially beneficial for applications that require a lot of random access, such as databases and web servers. Higher IOPS. SSDs can handle more IOPS input-output operations per second than HD hard disk drives. This means that they can process more requests at the same time, which can lead to a significant improvement in overall performance. Data throughput. SSDs can also transfer data at much faster than HDDs. This is important for application that require a lot of sequential access, such as video streaming and file transfers. Low power consumption. SSDs consume less power than HDDs, which can lead to a lower energy cost and longer battery life in mobile devices. RAID systems. RAID systems is data storage virtualization technology that combines multiple physical disk drives into one or more logical units for data redundancy, performance, or both. Then there are different rate levels, each with its own advantages and disadvantages. Then RAID 0. This level combines multiple disks together to make them work as a team, which improves the system's performance. I hope you can see the slides, guys.
No, we can't see your slides. Just now it's gone.
Sorry for the issue. I will. Okay, this RAID 0. This level combines multiple disks together to make them work as a team, which improves the system's performance. However, it doesn't protect your data, because if one disk fails, you will lose all the data stored on the entire array. RAID 1. This level creates an exact copy of your data on each disk in the array. It doesn't improve performance, but it provides excellent protection for your data. If one disk fails, you can still access all your data from the other. RAID 5. This level distributes a special types of data called priority across all the disks in the array. Priority information helps in recovering data if one disk fails. RAID 5 offers both data redundancy, the protection against these failures, and improved performance compared to a single disk setup. RAID 6. This level is similar to RAID 5, but provides even better data redundancy. It distributes to sets of priority information across the disks in the array. This means that even if two disks fail simultaneously, your data can still be recovered. However, RAID 6 also introduced some performance overhead due to the additional priority calculations it needs to perform. As a summary, RAID 0 improves performance but doesn't protect your data. RAID 1 provides excellent data redundancy but doesn't improve performance. RAID 5 offers a balance of data redundancy and performance. And RAID 6 provides even stronger data redundancy but has a bit of performance effect. Here, the RAID system can provide a number of benefits. What are the benefits? Data redundancy. The RAID can protect data from loss in the event of the hard drive failure. This is because the data is stored on multiple disks. So if one disk fails, the data can still be accessed from the other disk. Improved performance. RAID can improve the performance of data accessed by spreading the load across the multiple disks. This can be especially beneficial for applications that require a lot of random read-write operations. Finally, scalability. The RAID can be scaled up by adding more disks and as needed. This makes it a good choice for applications that require a lot of storage space. Then Pragit will continue this. Over to you, Pragit.
Thank you, Govindu. Network input output. First, let's understand what is a network interface card or NIC. NIC is a hardware component that connects networking devices such as computers and servers. It shares data over network and it provides essential functionality including support for input output interrupt, direct memory access, and data transmission. There are several types of NICs. The first type is Ethernet NIC. It was developed by Robert Metcalfe in 1980. It is widely used in LAN, MAN, and WAN networks. Ethernet NICs utilize Ethernet cables to establish a wide connection between devices. The second type is wireless network NIC. These NICs allows us to connect the device without using the cables. The third type is fiber NIC. Fiber NIC is specifically designed for fiber networks. Fiber NICs support different fiber connectors and enable high-speed data transmission over fiber optic cables. Let's move to the next slide. Here, function of the network interference, function of the network interface card. I will explain their key roles in network communication. Firstly, NICs are responsible for data transmission and reception. They convert digital data into an appropriate signal for transmission over the network. This ensures that data packets are accurately transmitted between the computer and the network. Then secondly, NICs handle media access control or MAC addressing. Each NIC has a unique MAC address assigned to it, which helps identify the device on the network. MAC addressing ensures that data is sent to the correct destination within a network. Additionally, NICs establish the physical layer connectivity between the computer and the network medium. Whether it's wired or wireless, NIC handles the transmission of data through electrical, optical, or radio signals. Let's move to the next slide. Here, network protocols. First one is TCP/IP. It means transmission control protocol or internet protocol. TCP is one of the main protocols of the internet protocol suite. Then second one is UDP. It's mean user datagram protocol. UDP is a lightweight data transport protocol that works on the top of IP. UDP is simple but fast, at least in comparison to the other protocols that work over IP. Third one is Ethernet. Next. Here. Now let's consider about packet processing. This is a format of a packet. I have entered the main part of data packets in this slide. These are source IP, destination IP, protocol, and data. Source IP is the address that represents the original sender of the packet. In packet processing, the sender IP is included in the source IP part. Next, we have the destination address. The destination address represents the intended reception of the packet. It specifies where the data should be delivered within the network. Let's discuss the protocol used for particular connection. Protocol define the rules and procedure for communication between network devices. In this part, different protocols are assigned, such as TCP, UDP, for different purpose. The next, data that should be sent to the destination is included in the data part of packet. Lastly, the packet is transferred to the network. Now let's move to the next slide. Here, input-output techniques for efficient network communication. First one, interrupt-driven input-output. This approach reduces CPU utilization and allows for efficient handling of incoming data to the NIC. The second one is direct memory access or DMA. DMA enables data transfer between the NIC and computer memory without CPU involvement. The third one is gather input-output. Allows for efficient data transfer by collecting data from different memory locations and transmitting them as a single unit. Then we are end of our presentation. Do you have any question? Okay, I think all are okay. Thank you for all attention to our presentation.
All right, thank you, Pragit and team. Yes, Who are the other team members? Any teams? Any individuals? No. I think there should
Am
be
I
a
audible here? Sir,
Yeah, please.
am I audible too?
Yeah.
Okay. So good afternoon, everyone. I'm Nishkia, and we have our group members, Venmi and Gayash. Okay, so before we move on to our topic for today, can you all see what's there in the presentation slide?
Yeah.
Okay, the name itself is the restaurant, right? So as you all can see, many people are having their food, some of them waiting for their food, and it's a place where plenty of orders placed. So simply, we can say it's a busy restaurant. So think about this busy restaurant where many hungry customers are waiting to be served. The kitchen staff must handle multiple orders at once, and each taking a different amount of time to cook. Their purpose is to ensure that everyone gets their food in a fair and an efficient manner. So how do they decide which order they have to work on? Well, just like in the restaurant, computers also have to make similar decisions when managing tasks. The brain of the computer, or the CPU, has to manage all the processes. It has to decide which process to work on and how much time should be allocated to each process. And do you all know how does the CPU decides it? It's our topic for today, which is scheduling algorithms. Okay, next slide, please. So this is our content of the presentation. Let's move on for the introduction. Okay, so simply scheduling algorithm means an algorithm that defines how much CPU time must be allocated to which process and when. This scheduling algorithm plays a crucial role in managing the flow of the process because they decide the order of the process and also helps in preventing bottlenecks and makes the tasks more efficient. And we can say the primary goal of scheduling algorithm is to optimize the system performance. Next slide. Types of scheduling algorithms. So there are two types of scheduling algorithms, which are preemptive and non-preemptive. Next, we'll have a look on what are they. Next slide. Preemptive scheduling algorithm. So preemptive scheduling is used when a process, as you can see in the process state diagram, when a process switches from the running state to ready state or from the waiting state to ready state. In here, what happens is the resources are allocated to the process for a limited amount of time and then taken away. And the process is again placed back in the ready queue if that process still has time to remain. In these types of algorithm, the system can pause or stop a process if a high prioritized process needs to be run or if a process used up its time limit. So for example, think about the restaurant scenario, which we have talked at the beginning of our presentation. So if a high priority order comes in, they may interrupt or temporarily pause the preparation of the low priority order. And after working through the high priority order, they again come back to the previous one. Or what they can do is they can give equal amounts of time to the orders and make the orders more effective and finish them within the time frame. That is what simply happens in preemptive scheduling algorithm. And for example, for this preemptive scheduling algorithm is round robin, which you will get to know during our presentation. Next slide. So the other type of scheduling algorithm is non-preemptive scheduling algorithm. Non-preemptive scheduling is where a process runs until it gets terminated or reaches the waiting state. So in this scheduling, once the resources are allocated to the process holds the CPU till it gets terminated. In the case of non-preemptive scheduling, it does not interrupt the process in the middle of the execution. Instead, what it does is it waits till a process completes and then it allocates the CPU to another process. So simply what it means is if a process begins, it continues until it finishes or reaches a natural stopping point. For example, we'll take the same previous restaurant scenario. Here, if order has been placed, they work with that order until it finishes and then move on to the next order. Likewise, it goes. So the non-preemptive scheduling works simple as that. Next slide. Okay, so whatever the algorithm type, the process should be allocated to the CPU, right? To process. So when assigning processors to the CPU, there are some considering criterions. So as you can see, the first one is arrival time. That is the time which a process arrives in the ready queue. And next we have waiting time. Waiting time is the time which a process waits in the ready queue. And the time taken to initiate or to start a process is called a response time. And we have burst time, or we call it CPU burst time. This is the time required by a process for CPU execution. And this time represents the actual time that a process needs to use the CPU for its task. And next we have the turnaround time. Turnaround time is the time taken to complete the process. It includes both time spent waiting in the ready queue and the time spent executing on the CPU. That means the waiting time and the burst time. So next we have throughput. Throughput is the number of processes completed per unit time. It's a measure of system efficiency because it represents the number of processes can handle within a given time frame. Next slide. Okay, so next we have the importance of scheduling algorithms. Why scheduling algorithms are actually important? To maximize the CPU utilization. Scheduling algorithm efficiently selects and allocates the processes to the CPU, and they try to keep the CPU busy as much as possible so that it helps in maximize the CPU utilization and improve the overall system performance. Also, it ensures that every processor gets a reasonable share of CPU resources and maximize the throughput. By now, you all know what is throughput is. That means which is the number of processes completed per unit time. So this scheduling algorithm ensures that more processes are completed within a given time. Also, it minimizes the turnaround time, which is the time taken to complete a process. Next slide. Next, we'll move on for some examples of CPU scheduling algorithms, which we are going to discuss today. We have first come, first serve, shortest job first, priority based, and round robin. So to discuss about this furthermore, I hand over the presentation to Gayasha. Over to you, Gayasha.
Thank you, Nushkia. Now I will explain first come first serve scheduling algorithm. This is a simple yet important algorithm used to schedule processes in a system. To help us understand this concept better, let's explore a real life example. Next slide. Imagine you are waiting in line at a grocery store and the cashier is handling customers one by one without any interruptions. That's how first come first serve scheduling works too. The CPU executes processes in the order they arrive, just like the cashier handling customers in the order they join the line. The CPU finishes one process before moving on to the next one, just like the cashier completes handling the customers before moving to the next. Now, let's dive a little deeper into first come first serve scheduling algorithm. Next slide. The first come first serve scheduling algorithm is introduced as the simplest CPU scheduling algorithm. This means that it is easy to understand and implement compared to another scheduling algorithm. Now I will explain the key steps involved in the first come first serve scheduling algorithm. It describes how the algorithm works and the sequence of events that takes place during the scheduling process. First one is the process that requests the CPU first is allocated the CPU first. In other words, the process that arrives earliest is served first. When a process enters the ready queue, its PCB is linked onto the tail of the queue. Each process in a computer has something called a PCB, process control block. It contains important information about that process, right? When a new process enters the line of the to use the CPU, its PCB is attached to the end of the queue, like adding a new person to the back of the line. Third one is when the CPU is free, it is allocated to the process at the head of the queue. Finally, when a process finishes using the CPU, it leaves the line or queue. So, in summary, the FCFS scheduling algorithm is like a simple line system. where the process that arrive first use the CPU first. The CPU works with the one process at a time. Then when it's done, it moves on to the next process in line. Next slide. Okay, imagine we have three processors. Let's call them P1, P2 and P3. These processors have different amount of time they need to use the CPU. P1 needs 24 milliseconds, P2 and P3 both need 3 milliseconds. If we follow the first come first serve order, meaning the processors are served in the order they arrive, the schedule would look like P1 goes first, then P2 and finally P3. We can represent this schedule using a Gantt chart. In the first scenario, where the process arrive in the order P1, P2, P3, the Gantt chart shows that P1 starts at time 0 and finishes at time 24. Then P2 starts at time 24 and finishes at time 27. And finally, P3 starts at time 27 and finishes at time 30. Now, let's talk about waiting time. P1 doesn't have to wait at all since it's the first process. But P2 has to wait for 24 milliseconds and P3 has to wait 27 milliseconds. To calculate the average waiting time, we adapt the waiting times for all processors and divided by the number of processors. In this case, it's 0 plus 24 plus 27 divided by 3, which equals to 17 milliseconds. Now we move on to the second scenario. In here, the processors arrive in a different order. Let's say P2, P3, P1. The Gantt chart would look different. Now P3 starts at time 0 and finishes at time 3. Then P3 starts at time 3 and finishes at time 6. And finally, P1 starts at time 6 and finishes at time 30. In this scenario, the waiting times change. P2 doesn't have to wait. P3 waits for 3 milliseconds and P1 waits for 6 milliseconds. The average wait time becomes 0 plus 3 plus 6 divided by 3 equals to 6 milliseconds. As you can see, this order results in a significant reduction in the average waiting time compared to the previous scenario. Therefore, we can conclude that FCFS scheduling may not provide the optimal or minimal average waiting time, especially when there is a significant variation in the CPU burst time of the processors. If shorter processes arrive later, they might have to wait for the long running process to finish, leading to increased waiting times and reduced efficiency. Next slide. The FCFS algorithm has some advantages that make it useful in certain scenarios. Simplicity. One of the main advantages of this algorithm is its simplicity. It's very easy to understand and implement. Fairness. This algorithm is fair because it treats all processors the same. This can be beneficial in situations where all processors have similar priorities or requirements. Third one is minimal overhead. You know that this scheduling does not involve complex calculations or decision-making processes. Simplicity reduces the computational overhead and makes it efficient in terms of system resources. Last one is predictability. This algorithm follows a clear order for executing processes. This predictability is useful in applications where the order of execution is important. Next slide. Right, look at this picture. You can see a lot of processors in here. Process 1 is on the CPU and other processors are waiting in the ready queue. P1 is in very happy and he said that, hooray, I could stay here forever. Anyway, I'm not going back to the end of the queue. But other processors are not happy and you can see that on their faces. P4 said that, hurry up, I'm waiting. You have been on that processor for ages. And P6 said that, look at the size of that queue. But scheduler said that, sorry, first come, first serve, right? That's the thing. So it's essential to note that FCFS isn't the most efficient scheduling algorithm. Now we see what are the disadvantages of first come first serve scheduling algorithm. Next slide. Disadvantages of FCFS scheduling. High average waiting time. If a long process arrives first, it can make shorter processes wait for a significant amount of time. It increases the average waiting time and reduces overall system efficiency. Conway effect. When a long process occupies the CPU, it results in delays for all processes, even those with shorter execution times. Last one is no consideration for process priority. A high priority process arriving later may have to wait behind lower priority processes already in the queue. This can cause a delay in critical tasks or processes that require immediate attention. Next slide. Okay, now when we will explain the shortest job first scheduling algorithm.
Thank you, Gayasha. Let us talk about shortest job first scheduling algorithm. This is an algorithm in which the process with the shortest burst time should be selected for execution next. Now you have a question, if the two processes have the equal burst time, and which process should be executed first. So in that case, shortest job first cannot be applied because the burst time of both processes are equal. Therefore, in this case, FCFS will be used. It means the one who arrived earlier will be first to be executed. This algorithm can be either preemptive or non-preemptive. Let's first talk about shortest job first scheduling algorithm when it is non-preemptive using this example. Consider the following set of processes with the length of the CPU burst given in milliseconds. Assume all the processes have arrived at the time 0. Since this follows shortest job first scheduling algorithm, we have to select which process has the shortest burst time. In this example, it is P4. Its burst time is 3 milliseconds. Therefore, P4 gets the CPU first and it is executed from 0 to 3rd millisecond. After that, we have to select which process has the shortest burst time among the remaining 3 processes. From you can see that it is P1. Therefore, P1 gets the CPU next and it is executed from 3 to 9th millisecond. After that, we have to select which process has the shortest burst time among the other remaining 2 processes. From that, we can see P3 has the shortest burst time and it is executed from 9 to 16 milliseconds. After that, P2 gets the CPU and it is executed up to 24th millisecond. I think you got a clear idea about this Gantt chart. Let us see how to calculate average waiting time and average turnaround time. First of all, we have to get the completion time. Completion time is the time which the process has completed its execution. For P1, it is 9. For P2, it is 24. For P3, it is 16. For P4, it is 3. Turnaround time is completion time minus arrival time. I think you remember the arrival time is 0 millisecond for all processes. Therefore, the turnaround time for P1 is 9 minus 0 is 9. For P2, 24 minus 0 it is 24. For P3, 16 minus 0 it is 16. For P4, 3 minus 0 it is 3. Waiting time is turnaround time minus burst time. The waiting time for P1 is 9 minus 6, it is 3. For P2, 24 minus 8, it is 16. For P3, 16 minus 7, it is 9. For P4, 3 minus 3, it is 0. To calculate the average waiting time, we have to get the total of the waiting time, which is 28, and it will be divided by 4 because there are 4 processors. From this, we can get 7 milliseconds for average waiting time. To calculate average turnaround time, we have to get the total of the turnaround time, which is 52, and it will be divided by 4. From that, we can get 13 milliseconds for average turnaround time. Now let us see shortest job first scheduling algorithm when it is preemptive. This is sometimes called shortest remaining time first scheduling. I will explain this using this example. Consider the following set of processors with the length of the CPU burst given in milliseconds, and the processors arrive at the ready queue at the time shown. This is the Gantt chart of this example. Let us see how to draw this. You can see that at the time 0, P1 arrived, and there are no processors other than P1. Therefore, P1 get the CPU first. At the time 1, you can see that P2 arrived and its burst time is 4 milliseconds. In this case, SJF algorithm works. It means the process which has the shortest burst time should be executed first. Therefore, at the first millisecond, P1 get preempted and P2 will get the CPU. At the second millisecond, P3 arrived and its burst time is 9 milliseconds. You can see that its burst time is greater than the P2's remaining burst time, which is 3 milliseconds. Therefore, at the P2 will not get preempted at the time 2. At the time 3, P4 arrived and its burst time is 5 milliseconds. You can see that P4's burst time is also greater than P2's remaining burst time, which is 2 milliseconds. Therefore, P2 will not get preempted at the time 3, and P2 will completed its execution at the 5th millisecond. After that, we have to select which process has the shortest burst time among the remaining 3 processes. Before that, you have to remember the burst time of the P1 is now 7 because P1 completed its first millisecond before it get preempted. Among the P1, P4 and P3, you can see that P4 has the shortest burst time. Therefore, P4 get the CPU next and it is executed up to 10th millisecond. After that, we have to select which process has the shortest burst time. You can see that it is P1. Therefore, P1 get the CPU next and it is executed up to 17th millisecond. After that, P3 get the CPU and it is executed up to 26 milliseconds. I think you got a clear idea about this Gantt chart. Now let us see how to calculate average waiting time and average turnaround time. First of all, we have to get the completion time. The completion time for P1 is 17, for P2 it is 5, for P3 it is 26, for P4 it is 10. The turnaround time for P1 is 17 minus 0, it is 17. For P2, 5 minus 1, it is 4. For P3, 26 minus 2, it is 24. For P4, 10 minus 3, it is 7. The waiting time for P1 is 17 minus 8, it is 9. For P2, 4 minus 4, it is 0. For P3, 24 minus 9, it is 15. For P4, 7 minus 5, it is 2. To calculate the average waiting time, we have to get the total of the waiting time, which is 26, and divided it by 4 because there are 4 processors. From that, we can get 6.5 milliseconds for the average waiting time. To calculate the average turnaround time, we have to get the total of the turnaround time, which is 52, and divided it by 4. From that, we can get 13 milliseconds for the average turnaround time. Let's see what are the advantages and disadvantages of shortest of first scheduling algorithm. First, we talk about advantages. First one is it reduced waiting time. Short processes are given priority, allowing them to be executed quickly, which reduces the overall waiting time for all processes in the system. Second one is it improved efficiency. By prioritizing short processes, the average turnaround time is minimized. This means that processes are completed more quickly. It will be leading to a improved overall system efficiency. Next, we talk about disadvantages. First one is if short processes keep arriving in the ready state continuously, there is a chance of starvation for long processes. These long processes may not get the chance to execute as short processes are constantly being prioritized. It will be leading to a potential imbalance in process execution. Second one is escape scheduling algorithm requires the knowledge of the required CPU time in advance. This can be a challenging situation where the exact CPU time needed for a process is not known or may vary dynamically. If the CPU time is incorrectly estimated or changes during execution, it can impact the scheduling decisions and overall system performance. Gayasha will explain the priority-based scheduling algorithm with you. Over to you, Gayasha.
Thank you, Venumi. Now we will talk about priority-based scheduling. Next slide. Have you ever prioritized tasks based on their importance?
Yes.
Yeah, we all know that we are students with busy schedules. We have multiple assignments and projects to complete, but some are more urgent than others. In this case, we would naturally prioritize the most important tasks and work on them first. Priority-based scheduling works in a similar way. It's like being a students who organize their tasks based on their priority level. The algorithm assigns priorities to different processes or tasks, just like you assign priorities to your assignments. Now let's explore more about how this algorithm works and the benefits it brings. Next slide. The shortest job first algorithm is a special case of the general priority scheduling algorithm. A priority is associated with each process and the CPU is allocated to the process with the highest priority. Equal priority processes are scheduled in first come first serve order. Next slide. In here, priorities are generally indicated by some fixed range of numbers such as 0 to 7 or 0 to 4095. However, there is no general agreement on whether 0 is the highest or lowest priority. Some systems use low numbers to represent low priority and others use low numbers for high priority. Next slide. Next slide. In this presentation, we assume that low numbers represent high priority. Consider the following set of processes assigned to have arrived at time 0 in the order P1, P2, P3, P4 and P5 with the length of the CPU burst given in milliseconds. As I mentioned earlier, priority-based scheduling allocated the processes with the highest priority. According to the given priorities, the scheduling order would be P2, P5, P1, P3 and P4. To calculate the average waiting time, we sum up the waiting times of all the processes and divided by the total number of processes, 41 divided by 5. You can see the average waiting time is 8.2 milliseconds. Now you know that priority-based scheduling is an important algorithm that determines the order in which processes are executed based on their assigned priorities. Next slide. Now, we talk about advantages on priority-based scheduling. Customization based on application needs. This scheduling allows us to handle various tasks with different levels of importance. It gives us the flexibility to customize how we schedule these tasks based on their priorities. Efficient resource allocation. This means that important tasks are given more importance, so they get the resources they need quickly. Improved system throughput. By giving more importance to certain tasks, those tasks are finishes more quickly. This helps the system works better and get more things done in less time. However, it's important to note that priority-based scheduling also has potential disadvantages. Next slide. Disadvantages of priority-based scheduling. Complex priority assignment. Deciding on priorities for processes can be difficult. It requires thinking about factors such as how important a process is, what resources is requires, and any limitations of the system like that, right? Lack of fairness. When processes have a higher priority, they use up most of the CPU time, leaving less time for lower priority processes. This can result in a various in response time and throughput between different processes, which can create different in how they perform. Starvation. If a process with the higher priority keeps coming in one after another, processors with lower priorities might never get an opportunity to run. This can cause a situation where certain processes are constantly delayed or even completely neglected. But fortunately, we have a solution for that. It is aging. Aging involves gradually increasing the priority of processes that wait in the system for a long time. For example, if priorities range from 127 to 0, I mentioned you that earlier. In this presentation, we assume that low numbers represent high priority. So 0 is high priority here. Okay, in here, we could increase the priority of a waiting process by 1 every minute. Eventually, when a process with an initial priority of 127 would have the highest priority in the would be executed. It would take no more than 32 hours for a priority 127 process to age to a priority 0 process. Next slide. Alright, now I will hand over this presentation to Venumi to explain about the round-robin scheduling algorithm.
Thank you, Gayasha. Let us talk about round-robin scheduling algorithm. This scheduling algorithm is designed especially for time-sharing system. It is similar to FCFS scheduling, but preemption is added to switch between processors. In this algorithm, a small unit of time called the time quantum or time slice is defined, and it is generally from 10 to 100 milliseconds. Let's talk about the implementation of the round robin. The processors are kept in the ready queue as a first in first out queue, as I showed here. New processors are added to the tail of the ready queue. The CPU scheduler picks the first process from the ready queue and sets a timer to interrupt after one time quantum and dispatches the process. After that, CPU will be given to the next process in the queue. One of the two things will then happen in this scheduling algorithm. First one is the CPU burst time of the process is lesser than the one time quantum. Let's say that the time quantum we assign is 5 milliseconds, but the burst time is only 3 milliseconds. So then what happens? The process itself will release the CPU voluntarily because the process only has 3 milliseconds of burst time, but the time quantum is 5 milliseconds. So it does not have to use the CPU for 5 milliseconds. After 3 milliseconds, it will release the CPU voluntarily. After the scheduler will be give CPU to the next process in the ready queue. Next one is the CPU burst of the process is longer than the one time quantum. Let's say the time quantum we assign is 5 milliseconds, but the burst time of the process is 10 milliseconds. Then the 5th millisecond timer will go off and it will cause an interrupt to the OS. What happens after that? The context switch will be executed to save the current state of the process, and the process will be put to the tail of the ready queue, and the scheduler will give the CPU to next process in the ready queue. Now let us see from example to how it happens. Consider the following set of processes that arrive at time 0 with the length of the CPU burst given in millisecond and time quantum taken as 4 milliseconds. In this example, processors are waiting in this order. Therefore, P1 will get the CPU first and it has to be executed for 12 milliseconds. But in the round robin scheduling, it allows to execute only 4 milliseconds in the one time quantum. Therefore, P1 will execute from 0 to 4th millisecond. After that, P1 will get preempted and CPU will be given to the next process, which is P2, and its burst time is 3 milliseconds. You can see that its burst time is lesser than the time quantum. So therefore, it is executed only for 3 milliseconds, which is from 4 to 7th millisecond. And after that, it will release the CPU voluntarily at the 7th millisecond. And CPU will be given to the next process, which is P3. And its burst time is also 3 milliseconds. You can see that its burst time is also lesser than the time quantum. Therefore, it is also executed for only 3 milliseconds from 7 to 10, and 10th millisecond P3 will release the CPU voluntarily. Then you can see there are no other processes other than P1. Therefore, P1 will get the CPU next and it will be executed from 10 to 14 because the time quantum is only 4 milliseconds. As you can see, P1 has remaining 4 milliseconds. Therefore, at the 14th millisecond, P1 will get preempted and P1 will get the CPU again to complete its last execution. I think you got a clear idea about this Gantt chart. Let us see how to calculate average waiting time and average turnaround time. First of all, we have to get the completion time. The completion time for P1 is 18. For P2, it is 7. For P3, it is 10. The turnaround time for P1 is, I think you remember, all the processors are arrived at the time 0. Therefore, the turnaround time for P1 is 18 minus 0 is 18. For P2, 7 minus 0, it is 7. For P3, 10 minus 0, it is 10. The waiting time for P1 is 18 minus 12, it is 6. For P2, 7 minus 3, it is 4. For P3, 10 minus 3, it is 7. To calculate the average waiting time, we have to get the total of the waiting time, which is 17, and divided it by 3 because there are 3 processors. From that, we can get 5.67 milliseconds for the average waiting time. To calculate the average turnaround time, we have to get the total of the turnaround time and divide the total of the turnaround time, which is 35, and divided it by 3. From that, we can get 11.67 milliseconds for the average turnaround time. Let's talk about advantages and disadvantages of round robin scheduling. First, we talk about advantages. First one is it is easy and simple to implement. Round robin scheduling is relatively straightforward to implement compared to more complex scheduling algorithms. It follows a simple circular queue mechanism where Each process takes turns executing for a fixed time quantum. Second one is each process gets a fair share of the CPU. Round robin ensures that each process receives an equal amount of CPU time. This fairness is achieved by providing each process with a small time quantum to execute before moving on to the next process in the queue. This prevents any single process from monopolizing the CPU. Third one is priority is same for each process. In round-robin scheduling, all processes have the same priority level. This means that no process is given preferential treatment based on its priority. Each process is treated equally and all the processes are executed in a cyclic manner. Let's talk about disadvantages. First one is throughput depends on the time quantum. The throughput of the system can be affected by the choice of the time quantum. Second one is waiting time increases with a small time quantum. When the time quantum is small, processors may not have enough time to complete their task within a single time quantum. This can be result in frequent preemption and context switches, and it also increases the waiting time for processors as they have to wait for their turn to execute again. Third one is similar to FCFS with a larger time quantum. If the time quantum is set to a larger value, the round-robin scheduling algorithm can behave similarly to the first-come, first-serve approach. In this case, processes are executed in the order they arrive, which can lead to a longer response time for processes with longer execution times. Fourth one is determining the optimal time quantum is challenging. Choosing the appropriate time quantum for round-robin scheduling can be a difficult task. It involves finding a balance between reducing context switching overhead and providing sufficient CPU time for each process to make progress. The optimal time quantum may vary depending on the characteristics of the workload and the system. Nushkia will explain real-world examples and future trends of scheduling algorithms with you. Over to you, Nushkia.
Okay, so as you all got a good understanding about how some of the scheduling algorithm works, let's see how this scheduling algorithm plays their role in real-world applications. Next slide. Okay, we have real-time gaming. Real-time gamings are interactive gameplay experiences, and it involves in handling complex graphics, responding to user inputs and all. And you all know that it needs to be quick and responsive. So scheduling algorithm makes sure that everything runs smoothly. Preemptive scheduling algorithms such as round robin commonly used in real-time gaming because it quickly switches between the game-related tasks and make everything run smoothly. Next slide. And another example we have is multimedia streaming and playback. So when we watch movies or listen to a music, we want that to be uninterrupted and smooth. So when it comes to a device, there are some other processes running in the background. So even if there are some other processes running in the background, CPU needs to give attention to all without getting those videos or music or whatever buffering or pausing. So scheduling algorithms such as priority scheduling can be used here to give higher importance to the required tasks and provide a good user experience. So these are only two examples of the usage of scheduling algorithm, but in every situation, scheduling algorithm plays a crucial role in managing the flow of the processes. So next slide. Next, we'll move on for some future trends of scheduling algorithms. Next slide. Okay, we have machine learning based scheduling. In here, what happens is instead of using fixed rules, it uses advanced techniques that allow the computer to learn from past experience and to make better decisions. So here it analyzes the past information, like how the computers have been used, what kind of tasks it handled, and by that it predicts what tasks are going to happen in the future. So this approach can be more effective and responsive when it comes to scheduling algorithms. Next slide. And next we have energy-aware scheduling. We all want our devices to last longer on a single charge, right? So this energy-aware scheduling focuses on that. It is a scheduling algorithm that uses special techniques to save energy. This helps in extend battery life and reduces energy waste. Next slide. Okay, security-aware scheduling. It is a scheduling algorithm which focuses on security factors to protect against threats and unauthorized access while managing tasks. Special techniques are used in here, like isolation. It means that ensuring different processes are running on the computer are kept separate from each other. So by doing this, if one task becomes attacked, it doesn't affect the others. Likewise, it uses some techniques and prioritizes the security needs. Next slide. So as a conclusion, what we have discussed so far on the topic of scheduling algorithm is, we have discussed what is scheduling algorithm, types of it like preemptive and non-preemptive, and we discussed about the criterions considering when assigning processes to the CPU, and we have discussed about the importance, examples, and real-world applications with some future trends. So we have come to the end of our presentation. Do you all have any questions? Okay, so as you all don't have any questions, we'll wind up the presentation. Thank you for spending your valuable time to listen to our presentation. Thank you.
All right. Thanks. Good presentation, team. So any other teams ready? Individuals?
So we have one more group presentation for today.
Okay. How about the other members? Shall we proceed or we'll move to next day? You can raise your hands if you'd like to stay. Or it seems the presenters are forcefully coming to the context. We'll proceed, or shall we keep it to the next day?
So we have asked the students, they were like, okay to continue with this.
Okay, to continue. Okay, then we'll continue. Good day, everyone. Good evening. Beginning of another presentation here. Can't hear you properly. A bit louder, please. Good day, everyone. Tired evening. Am I audible, sir? Yeah, audible, but it's not super clear. Okay, a bit loud. Good day, everyone. All right, now it's good. Beginning of another presentation here. We are group 15. As a last group to present, we have had the opportunity to listen to all the previous presentations and gain a comprehensive understanding of those topics. So today we will be presenting on the topic of mobile operating systems, which is the heart of every mobile device. So we are excited to share our insights with you all. Okay, without taking much time, sit, relax, and get ready. Let's dive into the world of mobile operating systems and explore the future of mobile devices.
Lakshya, I think it's muted.
Here's the content. In first section, we'll provide a brief overview of mobile operating systems and compare them to desktop operating systems. Then we'll look at the major mobile OSs and the architecture of Android and iOS. Next, we'll explore the main functions of mobile operating systems, including process management and memory management. In third section, we'll discuss the security and privacy challenges associated with mobile devices. Finally, we'll look at the latest trends and innovations in mobile operating systems and discuss how they are shaping the future of mobile technology. So Shania will continue from now. Shania.
Thank you, Lakshya. So, fasten your seatbelts as we embark on a journey through the fascinating world of mobile operating systems, unraveling the technology that has become an integral part of our modern existence. I know that this is a very familiar topic to all of you as BA students. So let's start our today's presentation with the definition of mobile operating systems. What is known as mobile operating system? A mobile operating system is a software that allows smartphones, tablets, and other devices to run applications and programs. Or we can say in another way, it is an interface between the device's hardware components and software functions. All right, guys, let's move on to the next slide. Now, we have some sort of idea what a mobile operating system is. So let's explore how it differs from the desktop operating systems. As you all know, a mobile operating system is a type of operating system that allows application software. But when it comes to desktop operating systems, it is the environment in which a user handles a personal computer. Then if we move on to the next slide, or we can say the next difference, mobile operating system handles cellular and wireless connectivity. But on the other hand, desktop operating system, it handles the software and hardware resources of the system. And if we look on to the boot time of mobile operating system, it takes a lesser time when compared to desktop operating system. And the next difference, as you know guys, so mobile operating system is optimized to work under fewer power requirements. At the same time, when it comes to the desktop operating system, it is not readily optimized for energy loss. All right, guys. So I hope that you guys had some idea about the differences of mobile operating systems and desktop operating systems. Then I'll move on to a small question. Can I have some examples for mobile operating systems? Can any one of you answer?
Apple OS.
Android.
Okay. What else? Yes, likewise,
BlackBerry.
BlackBerry. Yes, thank you for the answers. Likewise, there are various types of mobile operating systems. As you all know, we have BlackBerry, Google Android, Windows Mobile, then Harmony operating system, Palm operating system. Likewise, there are various types of mobile operating systems. So let's have a look on to these different types of mobile operating systems. Over to you, Lakshya.
Okay, thank you, Shania. Before approaching this topic, I'll introduce what is a kernel in brief. The kernel is the core component of an operating system that manages the system resources and provides bridge between the hardware and software layers. It is responsible for tasks such as memory management, process management. We'll explain what are those in a couple of minutes. Input-output operations, so like that. In this diagram, as you can see, these are the kernel of some main mobile OSs. So Android and Firefox OS are based on the Linux kernel. iOS is based on the Darwin kernel. BlackBerry OS is based on the QNX kernel. Windows Mobile OS, Windows NT kernel. Likewise, these are the kernels of these mobile OSs. Next, we'll move to worldwide market share up to now of some OSs. In past, the major two mobile OSs were the iOS and OS called Symbian. But with the time, Android OS has become more famous among the people, and still they are holding the majority. So in present, as you can see, the highest popularity holds by Android, and iOS remains second. So this is the market share worldwide in mobile OS. I'll hand over the presentation to Shania to explain you about Android and iOS, which are the two main mobile OSs right now. Shania?
Yes. So I had mentioned earlier as well, there are different types of mobile operating systems. But unfortunately, what has happened is some mobile operating systems, we can say they are now being discontinued, or we can say they are no longer actively supported. Now, for example, if you take Windows Mobile, so it has been discontinued in the year 2017. And also, you all know about the BlackBerry operating system. So it was much popular for securing message capabilities and physical keyboards. But however, what happened was BlackBerry transitioned to use Android as the primary operating system for its devices. The same thing happened to Symbian operating system as well. They also discontinued its development in new devices in 2013. So, from this slide onwards, in our presentation, I'll focus on two major mobile operating systems. All right, guys. So, as you can see in the screen, can someone tell me what are the major mobile operating systems? Okay, so that is Android and we have Apple iOS.
Seems no one is in the audience, dear. No one is answering. Please raise your hand, guys, if you are alive in here. All right, two. It's just two. Oh my God, it's getting hands up 13, 14. All right. 20. Okay. It seems there are people. All right, we'll go ahead.
All right. So next focus on the history and the evolution of Android. So Android is a mobile operating system developed by Google. And it was initially created by Android Incorporation, a company founded in 2003. And what happened was in 2005, Google acquired Android Incorporation. And also, the Android operating system continued under Google's guidance. As you know, the first commercial version we can say in Android is Android 1.0. So over the years, Google has released numerous major updates of the Android operating system with new enhancements, new improvements, or new features. So as of June 16, 2023, do you guys know what is the latest version? The latest version of Android is Android 13. And the good news is that Google is now, they are currently working on the next major release of Android. That is Android 14. Okay, so what about Apple iOS? Are you guys excited to know some facts about Apple iOS as well? So I will tell you some facts about Apple iOS. iOS is a mobile operating system developed by Apple Incorporation. So in 2007, they unveiled the original iPhone. That was the revolution in the smartphone industry. In 2008, Apple introduced iPhone operating system 1. And since the launch of iPhone in June 2007, there have been 16 major releases of iOS. So do you guys know what is the current major version of iOS? That is iOS 16. So I hope that you guys had some understanding about the major mobile operating systems. So Dineth will discuss about the architecture in mobile operating systems. Over to you, Dineth.
Thank you, Shania. So mobile architecture. So I think you guys also have some understanding about architecture of OS. The architecture of mobile operating system refers to the way in which the OS is designed and structured. The architecture of mobile determines how OS interacts with the hardware, how applications are run, and how data is stored. Next slide. Let's discuss about the Android architecture. So, next slide. So you can see the Android architecture in the slide. So I will explain each one in detail. So we have Linux kernel, Android libraries, Android runtime, application framework, and on top of that, system application. So Linux kernel. At the heart of the Android architecture lies the Linux kernel. It serves as the bottom layer, managing various drivers such as display, camera, Bluetooth, audio, and memory drivers. The Linux kernel provides an abstraction layer between the device hardware and the rest of the stack, handling critical functions such as memory management, power management, device management, and resource access. Next one is Android libraries. Moving up the stack, we encounter the Android libraries. These include both C and C++ core libraries and Java-based libraries, offering support for Android development. Example of these libraries includes SSL, Graphic, SQLite, WebKit, and OpenGL. These libraries provide essential functionalities to developers and enabling the creation of powerful and feature-rich Android application. So next one is Android runtime, or simply you can say ART. And it's serving as the engine for our application. ART, along with the libraries, forms the foundation for the application framework. ART is responsible for executing and managing the bytecode of Android application. Next slide. So, application framework. The application framework provides the classes necessary for creating Android application. It offers a generic abstraction for hardware access and manage the user interface and application resources. Services such as telephone, location, notification, and the view system are part of application framework. Developers can utilize these services to create robust and engaging application tailored to specific user needs. So last one is system application. At the top of the Android software stack are the system application. These include both native application provided with the Android implementation, such as web browser and email application, and third-party application installed by the user. System application offers you various functionalities enhancing the overall user experience of the Android device. So next slide. So here's a simple question, guys. Can someone answer?
We'll give some points. Agree? All right, guys, 10 points. You can raise your hands. First come, first serve. All right, there is a hand.
C.
Yeah, correct answer.
And this is your index, right? Oh, it's gone. What's your index? Hold on. I want to update the system. Yes, your index 2 missed. Who given the answer, D? I don't know. Your name.
22.
22.
60.
60.
27.
27.
H.
H. All right, thank you. All right, go ahead.
Let's talk about the iOS Act. Next slide. To understand the iOS layered architecture, imagine a layered cake where each layer has a unique flavor and texture, like chocolate, cheesecake, mousse, and cherries on the top. Likewise, iOS devices also have different layers that contains unique components responsible for performing specific function with the application and guarantee efficient and safe communication with the device hardware. So iOS architecture includes 4 layers that work as a shield from hardware changes. So Cocoa layer or application layer is responsible for the application appearance and how it interacts with users. Plus, it also contains critical iOS components that allow multitasking between application and user using the touchscreen to request commands. The media layer holds all videos, audio, and graphic frameworks that allows the user to listen to their favorite music or watch movies. And next one is the core services layer. And it contains essential technologies like the address book framework, the co-location framework, social framework, and HealthKit framework. And these are necessary to support device application. And it doesn't mean your application will need all these components, but they are available to be accessed at any time. And the last one is the core layer, and it's the closest one to the device hardware. It handles low-level functionalities such as networking, memory, and external accessories. Due to the layered structure, iOS application keep functioning effortlessly even there are certain hardware changes on the device. Plus, the malfunctioning of one layer doesn't affect others, and which makes it easier to test and debug each layer. So next one. So now we will focus on discussing the functions of mobile operating system. Over to you, Laksha.
Thank you, Dinet. Here I'm going to teach you about functions of mobile OSs. Mobile operating systems perform a range of functions to manage the device resources. So here are the main functions of mobile OS. First, the OS provides a user interface that allows users to interact with the device. Next, OS manages the applications on the device, ensuring that they are installed and running properly. This is called application management. Also, the OS manages the hardware resources of the device, such as CPU, memory, storage, like that. So data management is also done by OS. OS manages the data on the device, ensuring that it is stored and accessed securely. So now we'll go through process and memory management to more deeper. Before that, now I'll check whether you paid attention or not by asking an easy peasy question. So, okay, is there anyone who can answer this?
10 points.
Now you
All
can
right,
see the
Mihan.
question on the screen.
All right, Mihan.
Application management.
Yes, Mihan. The question answer is correct. Thank you for answering.
Thanks, Mihan. Added 10 points.
Okay. Now we can move to process management. What is process management? Process management is a core function of operating system that involves managing the execution of programs. A program is a process is a program in execution, and process management involves allocating system resources such as CPU time, memory, and iOS resources to these processes. We'll show you how Android and iOS, which are the major mobile OSs, do this management. How Android do process management? As you can see, there are 5 stages in Android process management: foreground process, visible process, service process, background process, and entry process. So let's get know what are these one by one. Foreground process. This is the process or the app currently in use by the user. Other processes can be considered foreground processes if they are interacting with the process that is currently in the foreground. Exactly, there may be few foreground processes and processes at any given time. Next one, visible process. This is a process that is not in the foreground, but is still affecting what is seen on the screen. For example, a foreground process may be the Facebook app, but the visible process is the app in the background of the screen, which triggered the Facebook app. Okay, you got it. So third one is service process. This is very easy to understand. This is a process that isn't tied to any app on screen, but is still doing something in the background, such as playing music or downloading files like that. So fourth one is background process. This is a process that is currently not visible to the user and therefore do not have any impact on the user experience. Exactly, these are apps that are paused and are kept in memory for quick access. And the final one is empty process. This does not contain any app data anymore. They are kept around for caching purposes to speed launch, but may be killed by the system if necessary. That is how Android do process management. Then we can move to how iOS do process management. There are 4 stages in iOS process management. Let's get know one by one. First one is creation stage. When a new process is created, it receives its own stack area and enters the new state. So then process can then move to the modification stage. Unlike most operating system, iOS doesn't automatically pass startup parameters to a new process when it's created. Because it assumes most processors don't need these resources. If a process does need either of these resources, the thread that created it can modify it to add them. Then process come to the execution stage. After a new process is successfully created and modified, it transitions to the ready state and enters the execution stage. During this stage, a process can gain access to the CPU and run. So final stage is termination stage. A process enters the termination stage when it completes its functions and shuts down, or when another process kills it. So now Dinet will go through our next key function. Dinet.
Next slide. Memory management. And what is the meaning of memory management? Simply, the meaning of memory management is the process of allocating and deallocating memory for mobile application. It is a complex task because mobile devices have limited memory resources. The goal of mobile operating systems memory management is to ensure that all applications have enough memory to run without running out of memory. Next slide. Okay. There are 2 main approaches to mobile memory management: static memory management and dynamic memory management. In static memory management, the amount of memory that is allocated to each application is fixed. This approach is simple to implement, but it can lead to memory fragmentation, which is when there are small blocks of unused memory that are scattered throughout the memory. Conversely, in dynamic memory management, the amount of memory that is allocated to each application can change at runtime. This approach is more complex to implement, but it can prevent memory fragmentation. Next. So both Android and iOS use a combination of static and dynamic memory management to allocate and deallocate memory for mobile application. So Android mainly use techniques called paging and garbage collection, while iOS uses techniques called automatic reference systems and memory pressure. So Android uses paging allows the operating system to move memory pages between physical memory and virtual memory. This allows the operating system to allocate more memory to application that need it, while still preventing memory fragmentation. Android also uses a technique called garbage collection, as I mentioned. Garbage collection is a process that automatically frees up memory that is no longer being used by an application. This helps to prevent memory leaks, which is when an application continues to use memory that is no longer needed. So next slide. So automatic reference counting, or simply you can say ARC. ARC is a compiler feature that automatically manages the memory usage of objects. When an object is no longer referenced by any other object, ARC will automatically free up the memory that was allocated to the object. And next, memory pressure. Memory pressure manage memory. Memory pressure is a measure of how much free memory is available on the device. When memory pressure is high, iOS will start to kill applications that are not currently in use. This helps to prevent the device from running out of memory. So both Android and iOS have their own strengths and weaknesses when it comes to the memory management. Android is more flexible and allows developers to have more control over how their application use memory. However, this can also lead to memory leaks if developers are not careful. iOS is more efficient and is less likely to have memory leaks. However, it can be more difficult to implement. So next. Next slide. So here's another question.
10 points again. All right. Yes, go ahead. What is that name? Unish. Unisha, right?
Yes, is the correct answer. Thank you, Unisha. Okay.
Yeah, next number, please, Unisha.
So the same number I gave you before.
All right. I'll update. Thank you.
Okay, that's it. Over to you, Shana.
Okay, so as we are more reliant on the smartphones and tablets to store personal information or maybe to communicate and conduct sensitive transactions, it is crucial for us to understand what are the potential risks, or we can say what are the vulnerabilities that comes with these advancements. So let's see what are the security and privacy challenges in mobile operating systems. So I'm not going to define all of these. I will pick some topics and I will tell you what that means. The first challenge. We have malware and viruses. So let me define it. Now, as you know, mobile operating systems such as Android and iOS, they are more susceptible to malware and viruses. So what will happen is these malicious apps and software can exploit vulnerabilities in the operating system. And the next one, we have App Store security. And we have device theft and loss, insecure communication channels, weak authentication and authorization. And after that, we have data leakage and insecure data storage. So what do you mean by that? As you know, mobile applications often handle and store sensitive user data. Now, for example, personal information, or we can say financial information. So, however, these inadequate data protection practices, or we can say insecure storage mechanisms, can lead to data leaks or unauthorized access to user data. And the next challenge that we are facing, that is privacy concerns with app permissions. Now, what happens is mobile apps often require access to various device features. So, user data provide to intended functionality. However, unknowingly, they may grant excessive permissions to app. It will lead to potential privacy breaches. Okay, we'll move on to the next one, operating system vulnerabilities. Now, as you know, mobile operating systems are complex software systems. It may contain vulnerabilities that may be exploited by the attackers. So, operating system updates or security patches are crucial for addressing these vulnerabilities. And the social engineering attacks. Do you guys have any idea about that? So, mobile users can be targeted through social engineering techniques, such as phishing or smishing. So, what happens is now attackers may attempt to trick users into revealing sensitive information. It may be through installing malicious apps or through deceptive messages, or it can be done using fraudulent websites. And the last challenge that we are facing is lack of user awareness. So users may not be fully aware of the security and the privacy risks associated with their mobile devices. So what will happen is this lack of awareness can lead to poor security practices, such as weak passwords or downloading apps from untrusted sources.
Shania, let me introduce various types of security measures to protect data which are used in OSs. So, mobile operating systems implement several measures to protect user data and prevent cyber attacks. Here are some of the key measures: secure boot process, application permissions. Likewise, these are few. I will explain one by one. First one, secure boot process. Secure boot process is mobile OS uses secure boot process to ensure that only trusted and authorized software can run on the device. This helps to prevent the execution of malicious code during the device startup. So applications permissions is mobile operating systems grant user controls over the permissions requested by apps. Users are prompt to grant or deny permissions related to sensitive data and device features. Next, we have data encryption. Mobile operating systems employ encryption mechanisms to protect user data. Data encryption is the process of converting plain text into a ciphertext to protect its confidentiality and ensure secure transmission on storage. Plain text means readable or understandable data, and ciphertext means encoded and unintelligible data. So it's a fundamental technique used in information security to safeguard sensitive information from unauthorized access or interception. Next one is two-factor authentication. Two-factor authentication. Two-factor authentication adds an extra layer of security during the authentication progress by requiring a combination of something the user knows and something the user processes. Biometric authentication is many mobile operating systems offer biometric authentication options such as fingerprint recognition or facial recognition. So likewise, biometric provides a secure way to unlock devices or authorize specific actions. Next one is regular security updates. Mobile operating systems release regular security updates to address known vulnerabilities and protect against emerging threats. So by implementing these measures and continuously updating their security protocols, mobile operating systems strive to provide a secure environment for users to protect their data. So Shania, now you can continue.
So, in our next slide, we'll move on to a comparison of some key features of security and privacy challenges in our major mobile operating systems. So, I will be discussing about the app permissions, App Store screening, and device encryption. So, the first one, we have app permissions. Next slide, please. So, if you look on to Android, it offers a more granular approach to permissions, now allowing users to grant or to deny specific permissions individually. So users have the flexibility to grant some permissions while denying others. But when it comes to iOS has a limited set of permissions. Users cannot customize them on individual basis. So app permissions are predefined by Apple, and users can only choose to grant or deny access to these predefined permissions. Secondly, I will compare the features related to App Store screening. Now, when it comes to App Store screening, there are significant differences between Android and iOS. So when it comes to Android, the Google Play Store has a relatively lenient approval process compared to iOS. So Android apps undergo automated review that checks for basic criteria such as malware or policy violations. But the App Store on OS, or we can say iOS, has a more rigorous approval process. So each app is manually reviewed by Apple's app review team. The next one, that is device encryption. Now, when it comes to device encryption, both Android and also iOS prioritize user data security by implementing encryption features. So Android supports full device encryption for data at rest, protecting user data if the device is lost or stolen. However, when it comes to iOS, it enables hardware-based encryption by default. So this will ensure that the user data is protected with strong encryption.
So I will compare their system updates, biometric authentication, and privacy labeling approaches. Okay, let's dive in. Let's start with system updates, which play a vital role in keeping our devices secure and protected. When it's come to Android, updates for Android are released by Google. However, due to the involvement of various device manufacturers, updates can be delayed and fragmented. This fragmented update process may result in slower deployment and security patches and updates, potentially exposing users to known vulnerabilities. On the other hand, Apple has more control over iOS updates, enabling them to provide timely security patches and major updates directly to all the supported devices. iOS users generally receive updates promptly, reducing the risk of exploitation of known vulnerabilities. So next, let's discuss about biometric authentication, a convenient and secure way to unlock your device and authorize actions. Android devices support various biometric authentication methods, such as fingerprint recognition and facial recognition. The availability and implementation of biometric authentication depend on device manufacturer and model. On the other hand, iOS devices offer biometric authentication through Face ID or Touch ID. These technologies provide a seamless and secure way to unlock the device and authorize actions, ensuring the user's privacy and convenience. Next. Privacy label. Moving on to the privacy labels, which provide insight into the data collection and usage practices of mobile apps. So you guys know how to check the privacy label in iOS devices? So no one, okay. I will tell you the steps. So first you need to go to the App Store and then search for the app that you want to search for privacy labels, and tap on the app and scroll down, and there's a section called app privacy, and here and there you can see the privacy label. So Android does not have a standardized privacy label system across all apps. In contrast, iOS introduced privacy labels, which offer users detailed information about an app's data collection and usage. And this transparency empowers users to make informed decisions about the apps they install, ensuring their privacy preferences are respected. And it's important to note that both Android and iOS continuously evolve their security and privacy features, and the specific implementation may vary with different versions and device manufacturers. Additionally, user behavior and practices also plays a significant role in overall security and privacy of mobile OS. Next. So this is the coolest part, future trends in mobile operating systems.
Okay. I know we all are very curious to know about new updates. So now we will be discussing the latest trends and innovations in mobile operating systems. So these are the new trends we are going to talk about. First one is we'll discuss it. The first trend we'll discuss is the integration of mobile devices with smart home devices. First of all, what is a smart home? What is a home automation system? A home automation system is a communication network consists of home sensors for access and monitoring of home environment without human intervention. Home sensors, devices, and appliances operate together as communication network to access and monitor the home environment. This allows users to control their home appliances using their mobile devices. So let's watch this video for better understanding of this trend.
Voice is missing. Voice is missing here.
Sorry, sir.
We can't hear it because the fun is with the voice. Because
Okay.
especially the last part, without voice, people would not understand what happens.
Definitely. Wait, sir.
Playing jazz.
Playing jazz.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, dentist at 9:30.
Fire off.
Fire off.
Open door.
Door open.
And we're gonna do one more.
Oh yeah. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open. Open door.
Repeat that.
Open door.
I didn't understand that.
Hey! Open door!
Play on the floor.
Get on the floor! Open the door!
Wrong voice command. Error.
Hey there. With a rock? Open door. Open door. Higher.
Higher volume.
Higher.
Cool, right? Okay. Now you can have a better understanding of what is the integration of smart home devices, integration of mobile devices with smart home devices. So the next one we are going to talk about is foldable screens. Foldable screens. Here you can see in the corner what is a foldable screen. Foldable screen are a new feature in mobile devices that offers a large screen size without sacrificing portability. A portable device is any device that can easily be carried. These screens allows users to have a large display when needed and fold down to a smaller size for easy storage. This trend towards foldable screen is likely to continue, and we can expect to see more devices with this feature. However, there are concerns about the durability of these screens and the cost of production. Foldable screens are also most difficult to repair, which could lead to higher costs for consumers. Next, we have